What's happening there, YouTube? Genji here, and today we're going to do a little bonus build here in StarRupture. For those of you who didn't watch my main playthrough, over 12 episodes I built this mega assembly line that constructs every item in the game, but as we drew close to the finish line it became increasingly clear that we were simply not producing enough low and mid-tier items in order to fuel our high-tier manufacturing at full efficiency. In fact, when we reached the final assembler building scanners, which is the most complex item in the base game before Content Update 1, that final assembler was only operating at 8% efficiency. So after I concluded the series, I began to wonder what kind of a base would be required to run an assembler manufacturing scanners at 100% efficiency. So that's the question that we're going to be tackling today, but before we can build anything new, I'm going to have to tear down everything that we've already created so that I can dedicate 100% of our resources to this new build. So, through the magic of editing, 90 minutes of deconstruction can be compressed into a mere moment, but before we begin any building, let's take a moment to go over the parameters for our build. For people who aren't familiar with automation games like StarRupture, let me quickly cover what I mean by efficiency. So in automation games, your manufacturing buildings need to be supplied input items in order to be converted into output items. Ideally, you want your machines running all of the time so that they're always producing more materials for you, which requires them to always be supplied with input items. In this example, I've built 2 smelters off of a supply of titanium ore that can only support 1 smelter, so each of these smelters is only working at roughly 50% efficiency. The other 50% of the time, they're standing idly by waiting for new materials to come in order for them to be able to process them into an output material. So our goal for this video is to have an assembler manufacturing scanners at 100% efficiency, meaning that it is never standing idle waiting for more materials to come in order to process them into new scanners. And to explain why that's so challenging, I'm going to use this third-party tool called Rupture Planner. No affiliation, I just like the way that they present their manufacturing chains, but I'll leave a link to it down in the description. So in our assembler, we're going to be producing 1 scanner every 10 seconds. That's 6 per minute. And each one of those scanners is going to require 2 lenses, 2 generators, and 12 stabilizers. And each one of those subcomponents is going to require its own list of subcomponents, and so on, 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 until we get to the very bottom of the chain here with the raw ores that we'll be extracting from the ground. This is going to require 1,252 calcium ore per minute, 947 Wolfram ore per minute, 1,632 titanium ore per minute, 1,419 helium per minute, and 2,280 sulfur ore per minute. This will require 10 sulfur extractors, 6 helium-3 extractors, 28 ore extractors for titanium, 16 ore extractors for wolfram, 21 ore extractors for calcium ore, which will then go into 16 smelters, 21 smelters, 28 smelters, so on and so forth, until we finally get to the end of the production chain with scanners. You can see at the top here that the grand total of our engineering project here is going to require 468 total buildings, all feeding their outputs into this one machine that will produce 1 item every 10 seconds. On the topic of resources, let's next talk about where we're going to acquire this vast quantity of materials from. In order to keep the number of satellite bases to a minimum, we're going to focus on the areas that have the highest concentration of resource nodes for each given resource type. So for starters, let's take a look at the southeast of the map here, where there's a valley containing 16 titanium nodes. We're going to set up a satellite base here called Titania that'll get us access to 2,400 titanium ore per minute. For Wolfram, I'll return to this central area that we used in my main playthrough to produce sulfuric acid. Here there are 9 Wolfram nodes that'll give us access to 1,320 Wolfram ore per minute. For calcium, we'll have to use 2 separate bases, one here next to the world engine, and one in the bottom right-hand corner of the map, as there's no single location that'll provide 1,200 ore per minute. The northern location has 5 nodes totaling 780 per minute, and the southern location has 4 nodes totaling 720 per minute. Helium we'll grab from here and here. Each location has 3 nodes producing 720 units per minute for a total of 1,440 per minute between them. And finally, just to the southwest of the world engine is a trench here containing 10 sulfur nodes. Combined, they produce 2,400 sulfur per minute. Alright, let's talk logistics. We'll be using V3 rails everywhere in our build, so we'll have a maximum throughput of 480 items per minute at every one of our rails. However, getting a full rail of 480 items from one of our remote resource harvesting bases to our manufacturing hub is not so straightforward, because the drone dispatchers and the drone receivers add a layer of complexity in the form of a 10-second dispatch delay after a dispatch has been fully filled. A rail moving 480 items per minute means that an item is entering our cargo dispatcher every 0.125 seconds, which for a stack of 100 items means that it takes 12.5 seconds to fully load a cargo dispatcher. Add a 10-second delay on top of that for the dispatcher to actually dispatch the receiver, and you're looking at around 24 to 26 seconds depending on how much instability there is with the rail transport. That 10-second delay means that even a fully efficient cargo dispatcher will still not deliver a full 480 items per minute through to a cargo receiver, and will sit idle for a significant amount of its operation. Through experimenting, I found that 3 cargo dispatchers is about the most that you can reliably fill from a single 480 item rail. However, even having 3 cargo dispatchers tied to a single cargo receiver does not produce an uninterrupted 480 items per minute out of that receiver. The only reliable way I've found to guarantee that you get 480 items out of a receiver is to have a 4th cargo dispatcher fed by a different rail to fill in the occasional gap left by the other 3. With that in mind, we'll use this kind of layout to dispatch our raw resources back to our manufacturing area. We'll first need to balance our impure, normal, and pure resource nodes to make as many fully loaded 480 item rails as possible. Then we can balance each 480 item rail across 3 dispatchers, and then use any remaining resources through a 3rd supplemental rail that runs here to the end into 2 dispatchers set to a low drone priority. These 2 receivers will receive the full capacity of our supplemental nodes, as well as whatever extra items are produced by our 480 item rails. These will be the extra 4th dispatchers that fill in the occasional gaps from our primary 3 to guarantee that our receivers are always producing an uninterrupted 480 items per minute. And now that we have a reliable influx of raw materials, we can actually begin to set up our manufacturing. While our drone receivers do technically have an output on each side, allowing for a total throughput of 960 items, for the sake of simplifying our rail distribution, I've opted to just use a single output, feeding a network of 8 smelters for each receiver, which will consume the total output of each receiver, and feed them into a V2 storage depot on the end. We'll copy this setup for each of our base materials that need smelting, so this one is for Wolfram. I'll copy this design for titanium, and then I'll copy this again for calcium next to this. And we'll try to consolidate all of our manufacturing, or as much as our manufacturing as possible, into this valley in the central northern part of the map. So I've named these Wolfram Ore RX1 and Wolfram Ore RX2. So our first step is going to be to get our dispatchers tied to these receivers and just make sure that we're getting the items that we expect to. So we'll set up each trio of dispatchers here on the Wolfram line to dispatch to one of our receivers back on the assembly line. And then we'll assign one of our supplementary dispatchers to each of those receivers. Alright, let's go see if it works. And there we go. I see solid green lights on all of our smelters and an uninterrupted flow of items at our receivers. So I'm going to say that this is going to work out the way I intended it to. So next we're going to duplicate this layout for titanium, but we're going to need to do some extra stacks here because titanium is going to require 28 smelters. So we'll need some additional receivers and some additional smelters, but we'll build that one on camera, copying this formula here. For most of our build here, we'll be using supported platforms as the basis for most of our 2nd and 3rd tiers. So we'll select a supported platform. We'll set this at the level of our 1st floor, offset this by 3 vertical positions, lock our Z with Y, put one at each of the 4 corners, slap a pillar on top of this, then slap a platform on top of each of these pillars, and now we can place a 2nd cargo receiver on top of the 1st. For our 3rd deck, we're going to use a similar setup. We're going to set this at the height of our 1st floor. 1, 2. Then use pillar supports. 1, 2, 3. And platform on top of that. Repeat it over here. Supported platform. Pillar supports. Then platforms, 1, 2. And now we can place our third tier cargo receiver. Like so. We'll place a rail connector in front of each one for distribution to our smelters once we build them. And then we can begin creating the decks for our smelters. We're going to reuse these pillars from the cargo dispatchers for our smelters, and since we have 3 cargo dispatchers, we're going to need 8 smelters for each cargo dispatcher. So we're going to do this in sets of 2, with a gap in between. 3, 4, 5, 6, 7, and 8. Supported platforms, we'll use the same layout that we used before. So we'll set this at the height of our lower deck and raise by 1, 2, 3. Lock our Z. 1 in each corner. And a pillar on top of each of these. Then cap those off of the platform. And then a pair of smelters. For the third deck, we'll start with supported platforms at the height of the lowest deck. Then pillars on top of that. 1, 2, 3. Platforms on top of that. And then our third deck of smelters, facing this way. There we go. Now to get these all set up with rail connectors. There's our output. All right, now to string everything up. And there we go. All right, there we go. 3 sets of 8 smelters each, all wired up on input and output, but we're not done yet because this is actually only 24 of the 26 smelters that we're going to need for titanium. So we'll have to set up one more mini stack for the remaining smelting. And there we go. An additional 4 smelters, bringing us to a total of 28, as well as some space along the bottom for 3 storage depot V2s to buffer all the outputs. So now we need to go to our titanium base and connect our dispatchers to these receivers. But first, let's name these. We'll call this ASMB, titanium or RX1, RX2, RX3, RX4. So between these 2 sides of this ravine, we should have 4 fully supplied 480 item rails of titanium here, and then 2 over here, with an extra supplementary rail in the middle. So we'll assign each one of these major rails to one of our receivers, and then split our remaining supplementary dispatchers between those 4 receivers. Titanium ore, going to titanium ore RX1, titanium ore to RX1. Titanium ore to RX1.
I'm so hungry I feel sick. Oh, I needed that.
Titanium ore to RX2. Titanium ore to RX2. Titanium ore to RX2. And then we're going to split these 2. We're going to do titanium ore, 1 to RX1, and we're going to set this to low priority. And this we're going to set titanium ore to RX2 and set to low priority. That way, the major dispatchers get filled first, and only when there's excess on the major lines will these supplementary receivers receive any extra. And these two supplementary dispatchers do still have their own dedicated feed for the extra titanium nodes that did not add up to 480 in this area. And same idea on this side. We have 3 major dispatchers, each of these with a dedicated 480 item rail, and then a supplementary dispatcher here that's going to receive the excess of these 2 rails plus its own extra. I believe there's 120 items per minute coming in on this rail. So titanium ore to RX3, titanium ore to RX3, titanium ore to RX3, titanium ore to RX4, titanium ore to RX4, titanium ore to RX4, and we're going to dedicate this last one. We're going to do this to, I guess, RX3, because RX4 only has a handful of smelters on it, so it doesn't really need an extra dispatcher, as those smelters aren't going to be consuming the full output of a receiver. Alright, our receivers are full, so now we'll set all of these smelters to make titanium bars. Titanium and titanium. Alright, now we're manufacturing 1,680 titanium bars per minute. For calcium, we're going to need 21 smelters, so we're going to have 8, 16, and then an incomplete third row. We're gonna set this up right next to our titanium smelting. We're gonna leave a gap of 1, 2, 3. Actually, it's probably gonna go right where I'm standing. That always tends to happen. We're gonna leave a gap of, let's set our Z here. 1, 2, 3, 4, 5. And this is so when we have a rail connector and a rail connector, and we have space here in between each row to move items back and forth, because once we actually get into our fabricators and our furnaces and all that, we're going to need to be moving these items around via rails rather than dispatchers. So we're going to need some lanes to maneuver items around in. Okay, there's inputs and outputs wired on calcium. Now to get this some power, name our receivers and get them connected to our dispatchers over at our calcium bases. Let's head over to, I guess let's start with calcium east. I just worry, as soon as I pop in here, we're gonna get attacked. I probably should have set this up during our rupture. There they are. Alright, calcium ore, RX1. Oh god. Show me those booties.
Reloading.
Alright. Back to work. Calcium ore RX1. Calcium ore RX1. These are our main dispatchers here. So you guys are going to be calcium ore to RX2. Calcium ore to RX2. Calcium ore to RX2. You're going to be calcium ore to RX3. Alright, we're ready to set each of our smelters to make calcium blocks here. And we're off. 21 smelters, turning calcium ore into calcium blocks. The Great Wall of Smelters. So we should have enough room here for 3 storage depot V2s. So let's set that up to buffer the output of each of these. Set each one of these to store calcium blocks. Calcium blocks. calcium blocks. And there we go. Okay, with all of our basic smelting done now, I think we can move on to our fabricator stacks. Let me figure out where we're going to squeeze these fabricators for each one of these materials. And we can use a similar setup because the smelters are similar in height to fabricators. So we're going to use the same construction to make stacks of fabricators for our tier, I guess these would be tier 2 materials, right? So our copper wires, our calcite sheets, so on and so forth. So for Wolfram bars, we're going to need 12 fabricators producing Wolfram wires. So I'm going to squeeze these right next door to our production for Wolfram bars. In fact, we'll even reuse the same pillars. We're going to face these in this direction. And we're going to create 1, 2, 3, 4, 5, 6. We're going to create 2 stacks of 6 fabricators. That'll give us our 12 fabs necessary for all of our wire. Okay, there's 2 floors of 6 fabs each. This will be all of our wire production here. And we're also going to need a single fabricator making Wolfram plates for something down the line. I can't see it. But we'll face this in this direction and we'll slap in a single plate fabricator. We'll fill the rest in with platforms. Okay. Rail connectors. And then a single output for you. A single input. There we go. That's all of our inputs wired. Except for you, but you're a special case. Let's check our ratios here. Which I probably should have done before I built all this. So these are going to produce Wolfram wire at a rate of 2 every 4 seconds. 30 per minute, so 30 times 6. So each one of these is going to, or each floor of this fab assembly is going to consume 180 items per minute. So you should actually be able to run all of these off of the output of a single depot V2 here. Because we're going to have 480 items out of our depot. This is going to be 180 here. This is going to be 180 here. That's 360. Our single plate producer here is going to consume another 60. That's 420 out of our 480. But we'll find out as soon as I wire all this up. Let's put you here. I guess we can go like this. Input here. Dot, 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 dot. And then like this. We'll see. The math checks out, but we'll see how the distribution actually works out. Let me get up here. Well, actually, I'll just start at the bottom here. So we'll sell these to Wolfram wire. Wolfram wire. And then you are going to be Wolfram plates. 1 every 1 second, or 60 per minute. Now, it's going to run under maximum efficiency until their input buffers begin to back up a bit. Which is why I've not put a output on any of these yet, because I want their internal storage buffers to fill first. That way our storage depot has a chance to catch up on delivery for this. Actually, you know what? Instead of doing it like this, I'm going to take this output here. Just take a little bit of stress off of this rail. Now we're looking down here. We're building up our internal buffers. This nice long manufacturing time means that we have extra time to get items into the input buffers here. It looks like everything is running at full efficiency without needing to stop. We'll say that's squared for our Wolfram wire production. Next, we're going to need to produce Wolfram powder. We're going to need 24 furnaces producing Wolfram powder, consuming 713 Wolfram bars per minute. Okay, I was actually off with the calculation for Wolfram wire consumption. I used this number here, 2 to 4. This is how many Wolfram wire it's making. It's actually consuming 1 every 4 seconds. So this whole lineup of 12 fabricators here is actually only using 180 Wolfram bars per minute. Plus the 60 from up there, we've got 240, which means we have an additional 240 Wolfram bars available on this string, and then we have our full 480 bars available on this second storage depot in order to feed our stack of 24 furnaces that are going to be making Wolfram powder, and they're going to be consuming about 720 per minute. So I'm going to set that stack of furnaces up right here behind this. We'll grab some furnaces. And I guess we'll start right here-ish. This is all valid. Okay, good. So that we can grab straight off of this line here. So we'll line this up with this, right in the center here. We'll go out 1, 2, 3, and then one more, so that when we put a rail connector right here, we have a 3-tile gap between these two stacks. So we'll use this as our starting point. 1, 2. 1, 2. 1, 2. 7, 8. These will be connected to our existing string of Wolfram wire. Let's say I'm hesitant to start stringing these across this aisle directly, because I would like the option, if necessary, to put a full stacked line of connectors, right? Where we do 1, 2, and then 3, and then run 3 rails vertically along the same tile. But I suppose what I can do, since these are aligned, I don't actually have to go from here in this direction. I can just go from here to like here. And then we can run this from here to here. And then we can run this backwards from here. Like this. And then we can also run it forward from here. I like that a lot more than having to sling like another rail connector here in the middle, and then going from here to here, and then from here back to here, and then from here to here. It looks a little bit nicer to have everything at clean right angles. We're gonna have to change up our formula here a bit, actually. We're only gonna be able to stack 2 furnaces because, as you can see, these guys are a little bit higher than fabricators. So if we're doing 1, 2, 3, 4, 5, 6, 7, 8, if we stack 2 of these, we're gonna get 16, which means we're gonna need to continue to stack down here. But this is all of the fabricators that we're going to have that are going to get fed from this line. Actually, let me finish wiring these up just so I don't lose track of which ones need to be connected to this. So we'll do this and this. Rail here, here, and here. And this will be the end of the line for this. This will be fully consuming 480 item rail. So to put a second floor on this, we'll probably have to go straight from the bottom. 1, 2. So no offset here. Just supported platform level with our existing row. Then 2 pillars. Cap them off.
I'm so hungry, I feel sick.
And then a second row of furnaces on top. And we've gone over our power budget as well. I think what I may wind up doing is having a separate power base feeding into here. If I can find a spot to put that, and then we can put, instead of having a bunch of these 200-watt turbines, we'll do solar generator V2. In fact, let me get that set up real quick. And we'll lose this. This. And this. I'll leave one just to keep our teleporter powered up separately. We'll drop our base core here. Power. Solar generator V2. I think we can only fit 4 of these, but that's all we're gonna need. 1, 2, 3, 4. And then we'll run a transmission line. Rail support. And there we go. Okay, where were we? Okay, so there's 2, 4, 6, 8, 16 out of our 24 that we need. It's unfortunate we can't get a third stack here. Well, maybe we can. Let me see, because we can actually lift up our supported platform a little bit more. Let's see, if we raise this all the way up and then stick pillar, 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 pillar. Ooh, we might have just enough. Let's see. Furnace. It would help if we put a platform down here. Hey, alright, so we can do a stack of 3 furnaces. We're just gonna have to change our pillar arrangement just a tad. Luckily we left that space available for these extra pillars. Okay. So we'll add 8 more on top of this, and this will give us all 24 furnaces that we'll need for Wolfram powder. That is a wall of furnaces, my god. Alright. What's our power consumption look like here? Let's do info. Well, I guess we just select Wolfram powder first. Info. 1,300 of 4,000. Nope. I guess we're pulling a little early here, that's fine. Let's get the rest of these strung up. Alright, so for these guys, let's run this directly out of this container, this storage depot, into this. I don't think that'll interfere with any rails that we happen to run along the ground here. Why? There we go. Wire the rest of these up. There we go. Inputs wired. Before I string up the outputs, let me see what our output ratio looks like. So we're producing 3 every 2 seconds. Each one of these is producing 90 a minute. So on a 480 item rail divided by 90, we can fit the output of 5 furnaces. That means we're gonna have to break our 24 furnaces up into 5 separate groups of 5 furnaces each. So we'll have 5 rails of Wolfram powder. 1, 2, 3, 4, 5 out. 1, 2, 3, 4, 5 out. Yeah, that's probably the best way to do it. So then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of these left. So there we go. We have broken into groups of 1, 2, 3, 4, 5 in one group. 1, 2, 3, 4, 5 in our second group. 1, 2, 3, 4, 5 in our third group. Then 1, 2, 3, 4, 5 in our fourth group, and 1, 2, 3, 4 in our final group, for a total of 24 furnaces. So let's go set all of these to produce Wolfram powder. Wolfram powder. Wolfram powder. And here we go. We're already backing up here at the end of the line, which means we're definitely supplying enough Wolfram bars to fuel all of these furnaces. Look at them go. They fill up the entire screen. This is so many furnaces. The Great Wall of Furnaces. So we'll let those run for a bit. And that takes care of our Wolfram powder production, and I think that's everything that we're going to need Wolfram bars for. So now we're going to move on to titanium. I guess let's get the hard part out of the way here. So we have 3 strings of this, because we're going to need 1,128 bars per minute for rod production. Specifically for tubes, but that's going to require 38 fabricators. Give me just a fabricator. I want to see this recipe. So titanium rods consume 1 every 2 seconds. That's 30 per second times 38 is 1,140 titanium bars per second divided by 480. So we're going to need 2.3, or basically all of our 480 item rails dedicated almost entirely to titanium rod production, with a mere 400 going to titanium sheets and another 72 going to titanium beams. Oh, actually, no, we have 4 here. So yes, we have 1, 2. So these 2 outputs of titanium bars will be dedicated. Probably these 2 and this one over here will be dedicated to titanium rods, and then this one will be dedicated to titanium sheets, with a little bit left over for titanium beams. But before we can decide any of that, we need to get manufacturing set up. So let's figure out where we're going to be able to squeeze in 38 fabricators for rods. So 38 fabricators for rods. It's going to be almost 13 stacks of 3 fabricators on top of each other. So I think we'll run this way. We'll run this way against the rest of these rows, because we've kind of hit the rim of our crater here. And after this point, we're going to start gaining elevation, so our stacks aren't going to be nice and flat. So if we do it this way, we'll get as many flat stacks as we can. 1, 2. And we can't even do these here. 1, 2. 1, 2. 1, 2, 3, 4, 5, 6. Can we break that up? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I guess we'll just have to place one all by itself out here. Because these stacks only need to be 3 deep, we don't need to do our previous setup for columns, so we can do 1, 2, 3. Then 1. This will allow us to do 1 here, then 1, 2, 3. And this should give us all the support we need to put these fabricators on here. So we'll go back to supported platform. 1, 2, 3. 1, 1, then 1, 2, 3. And if we cap this and cap this and switch back to fabricators, we should now be able to slap deck number 2 on. And deck number 3. Go in. There you go. Okay, there's 12 stacks of 3. So we'll have to put 2 more furnaces somewhere else. Alright, let's put rail connectors on these stacks that we have here, and we'll still need to put 2 more fabricators somewhere. We'll get these railed up and connected, and then we'll figure out the remaining 2. Okay. Connectors all in. Let's put some rails on. Now I'm only going to put the actual input rails into the machine at this point, because we still have to logically separate groups of fabricators and work out the exact number of fabricators that we can feed off of each of our 480 item rails. Okay, there's all of our input and output rails connected to the machine itself. Now let's do a little math to figure out how many of these we can support on each of our 480 item rails, which are going to be coming from here, here, and here. So we will need to create a little lane to bring these to their final destinations. But first, some math. So we're going to be making titanium rods here. Titanium rods are consuming 1 titanium bar, producing 1 titanium rod every 2 seconds. That's 30 per minute. We can fit 16 of these on each of our 480 item rails. And the way that we have this broken down, it's about every 5 stacks of fabricators here. So if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We can run 15, technically 16. We could leave 2 of this remaining stack to a different rail. So let me wire up at least up to here, and then we'll figure out if there's a way that makes sense to split this between 2 rails, or if we should just put one of these onto the next stack. So bring this to, let's say, here. And we'll set up our secondary rail like this. So this will end up looking something like this. Actually, I should put these rails down first, so these need to come out. And then we can run our second set of rails like this. And we'll end this on this side here. Because if we put it on this side, then it becomes difficult to move this line forward again. But from here, we can take this down this direction. Or directly into here. I'm not sure how I want to do this just yet. I do want to avoid touching these two, because if this goes here, these 2 towers become one object. Maybe I do this. There we go. That'll avoid having to put any new rails down there. Like that. That should feed these 15 fabricators. 30 times 15 of 450. So we can technically run 1 more of these. Let's say this. For a total of 16 fabricators. And then these 2 will have to figure out a way to get this onto this stack here. At the very least, this rail and the output of this storage depot is now fully consumed. So now we have to work on getting this one over to this stack here. We'll take this out into this rail connector. We'll run this into this rail connector. So I'll put this rail down first, but I can then add this rail connector in here in case we need to run another rail through here, like this. And then this is going to go, this needs to go into this machine. So maybe we go to here. Yeah. And this can go straight ahead. And then make a right-hand turn. And now we're going to need to pick out another 16, well, we're going to need these 2. So this is 1, 2. So I should actually, instead of running this straight through, I should put a rail connector here. And then this can run here to here, and then also to here and up to here to run these 2 machines. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we can run like 1 more from the 3rd row if we take the bottom 2 rows off of these stacks. So we'll do this through here. Instead of looping it back around again and giving these bars a much longer route to go through to get to their designated machines, you just loop this up here like this. You know, let's squeeze 1 of our 2 extra machines that we need. 1 here and then 1 down on this end. Actually, you know what? Let's do them both here, because we have the pillars here for it. This is going to be a little off. So let's delete this machine. We'll let this machine here live on this string. And then we'll put a fabricator here, and here. We'll squeeze our rail connectors in here and here. We'll see if that's even possible. No, we can't get this in here anywhere. So let's do this. We'll take these two out. We'll put a rail connector here and here. We have to put this a little off kilter, but it should be fine. Like this, and then like this. We're doing some crazy stuff here to make this work, but there's our extra 2. So this gives us 6 and 6 makes 12, plus 2 is 14, 15, 16. So there's our maximum. So this whole top row here will then be running off of this 3rd storage unit here. Take rails from here. We might be able to just go straight up here like this. That's crazy, but it works. So then we can take this from here to here. So that should be 180 items per minute, right? 30 items per minute times 6. So that leaves an additional 300 items per minute to allocate to some of our other things that we need to build here. We still need to make titanium sheets and titanium beams, but for right now, we need to figure out how we're going to string up the outputs of these machines to collect these into another storage depot for use elsewhere. So, time for more math. So, we're producing 1 every 2 seconds. So this will actually be pretty easy. It's the exact same split as our inputs. So we're taking 30 items per minute off of these. So we're going to split this into 15 to 16 machine groups times 3, right? So we'll have two that are fully saturating a 480 item rail, and then we'll have another 6 on a partially full rail. We'll do the same groupings that we use for the inputs to the outputs, and then we'll direct those. I guess we're going to have to direct them to this side, because we're going to want them on the inside of our assembly crater here, rather than having to string them back in here from outside. So our collection will probably go right here on the end. We can do 2 storage depots, one here, one here. Actually, you know what? 6 machines is not nearly enough to justify a storage V2, so we'll do, and we're out of resources, so let's break this. We'll do 2 storage depots down here, and then a storage depot V1 up top here. How's that? For these 6 machines, let's give this the expanded base, like so. So it lines up in the center. Perfect. Okay, let's string this up. I think what I'll do, just to save us some extra space here, we could put another entire stack of manufacturing, is I'll run this into, say, the side here. We'll feed this into here, and then we'll feed this into this side of the same storage unit, and then we can have 2 input rails at 480, and then we can do 2 output rails from the same unit. So as long as we're feeding 480 and 480 into this, so 960 total, and we can also feed 480 and 480 out of the other 2 connectors. So we'll get rid of this, and this will save us some room that we can put a whole other manufacturing stack here. Okay, wired into there. And that should be all of our titanium rods online. So let me go and assign a recipe to each of these, and we'll see if it all works. And there we go. That should be everybody set to make titanium rods. All right. We've got bars flowing out. These fabricators are running quick enough that they're going to be awaiting input for a bit until their output buffers fill up. But after that, they should be running at 100% efficiency. All right, I'm going to flip the switch on our storage here to allow these guys to start unloading their titanium rods. And get up here to this smaller depot. Set this one to rods. And we should see... Well, we'll see them one at a time begin to unload their rods. Once this one's empty, then this one will be allowed to empty, then this one will be allowed to empty, because each machine will fully saturate the bus until their internal buffers are empty. So the ones downstream don't ever get a chance to use the rail until the ones upstream have finished taking their turn on it. Meanwhile, let's begin setting up titanium sheets. So we said this last string here had 1, 2, 3, 4, 5, 6 rod fabricators on it for a total of 180. So that means that this, I believe this is the one here that goes up to that. Yeah, so this storage unit still has 300 items per minute, 300 bars per minute worth of capacity. Well, that's unfortunate. Plus whatever we have in this guy here, which I'll have to add up in just a minute here. We're going to need a total of 432 per minute for our titanium sheets. So we can take this 300 plus another 130 from this, hopefully if we have it. Looks like this one's running 1, 2, 3, 4 smelters, which is 60 items per minute. That'll give us a total of, what, 240 into this. So that's definitely enough of a budget to combine the outputs of these two to run the 15 fabricators that we're going to need for titanium sheets, but we'll have to do that as soon as this rupture is over. For 15 fabricators, that means 5 stacks of 3 fabricators. Let's align this with our fabricators or our machines here, I suppose. So we're going to intake from this side. We'll do 1, 2, space, 3, 4, space, 5. This will bring us pretty close to the edge, not exactly. Close enough. Do our supported pillars, and we'll just continue this layout, even though we don't need it here, just because we're making this a part of this stack, per se. So we'll do 1, 2 in the middle, 1, 2 in the middle, and we don't need it for this side. And then we'll lift this up by 1, 2, 3, lock our Z, 1, 2, 1, 2, and we don't need that here. Pillars, unlock our Z, 1, 1, 1, 2, 3, 1, 2, 3. Cap these off. No. Cap. 1, 2. Fabricator time. Loading from the front. We'll bring these up to here. 1, 2, 3, 4, 5. There's 15 fabricators for titanium plates. And we're also going to need 4 fabricators for titanium beams. And I think what I'll probably do is come over here and we'll reuse some of this top space here. We have space for 1, 2, 3, 4. And that'll still give us enough room, maybe. Let's see, if I drop this here. This will give us still enough room to drop in a storage depot V2 for storing whatever it is that we're making down here. Wolfram wire, I think. If we drop this here, and we can do fabricators. We'll do input facing this way. 1, 2, 3, 4. And then we can bring our lineup from down here or in here. So we'll worry about that in a bit. Let's make sure that we get all of the titanium bars that we're going to need into these guys first. Before we can do anything, we're going to have to stick some input and output connectors on these. Okay. So, let's do a little math here. So we have 15 fabricators running at, let's see, what are they consuming? Put this recipe in here. So we're consuming 1 titanium bar every 2 seconds. That means we're running, each one of these machines is consuming 30 items per minute times 15. So we have a demand of 450 titanium bars here and we said between our 2 remaining storage depots for titanium bars, we had 300 plus 240, which is 540. So we'll need to combine the outputs of this and this storage unit to feed into this in order to supply it with all of the titanium bars that it's going to need. Fortunately, we don't have to worry about doing any of the balancing on our own. As long as these machines are connected to these guys, they'll automatically pull, which is the benefit of using a pull system instead of a push system. So we don't need to push a certain number of items onto the rail coming over here. We just need to make sure that these machines all have access to, divided between these 2 machines, the appropriate number of bars. So we'll string these up in this direction. There we go. And rather than loop them through each other, I will have our input line coming in here. And then we'll have one coming up this direction, and another coming up this direction. Now I do need to make sure that both of these, one here into this, and one here into this, are feeding into this. And in fact, I may pull this back and do this here, just so we're not clogging the middle of this lane. Let's put this here. We'll do one into here. We'll do one into here. And then one straight across. There we go. So we'll bring all of these forward so that our output is on this side of the tower here. Actually, I need to calculate that before I get too far ahead of myself, because these are, if I activate this for titanium sheets, we're consuming 1, but we're producing 2, so we actually have an output of 60 on each of these, which is a total of 900 items per minute, which is too much for a single rail, so we'll actually have to divide this in half, or at least separate 480 onto one rail and then the rest onto a second. So let's see, at 60 items per minute, 480 divided by 60. So we can take 8 of these machines together, the output, we can combine the output of 8 of these machines to fully saturate a V3 rail. So we'll take 1, 2, 3, 4, 5, 6, 7, 8. So bring this down. Let's bring it down like this, and then we can use this to actually bring the items off somewhere. And then we'll combine the other, what, 7? 1, 2, 3, 4, 5, 6, 7. Then we'll take this out this direction. We'll loop this down here. I guess I'll have to go around this, because these aren't quite deep enough. And there we go. So now we have our outputs here and here. So let me set the recipe for all these machines to sheets. This is already full. Sheets and sheets. There we go. Now we should be supplying and operating all of our sheet fabricators. Everything's looking good. I don't see anybody shutting down and complaining, waiting for input. Now we can turn our attention to our beam constructors, or fabricators over here. Our beam fabricators. We'll set these to titanium beam, titanium beam, titanium beam, and titanium beam. So these are consuming 1 every 3 seconds, which is 20 items per minute. So these 4 will consume a total of 80 bars. So we need to get, say, the output of this guy up over here, or this guy. Doesn't matter, because the demand for this stack is split between these two. It shouldn't really matter which one we put over in this direction. But first I should probably put some connectors on it. That might be a smart idea. Alright, obviously we're going to string this in this direction. And bring our output back in this direction. If I put this here, I might be able to just go up and over the top of anything that might get in the way, like so. There we go. beams are on the way. We don't have anywhere to direct them to just yet, but we'll let these guys fill up their internal buffers. Now, I'm not quite sure what to do with this yet. With all of these online, that takes care of everything we need to make out of titanium beams. So now we can move on to calcium. With calcium, the only thing we need to make with calcium is calcite sheets. And our calcium is right here, or our calcium blocks are right here. So we'll set up our calcium manufacturing down at, well, I guess we could start at the end of this line, right? So we don't have to string this all the way back up and then back down again. Oh no, we need to make calcium powder as well. Ah. So our calcium blocks are right here. And we'll need to make calcium sheets and calcium powder out of these blocks. We'll need 24 fabricators for calcite sheets and 28 furnaces for calcium powder. So we're gonna need another whole row here of calcium. So let's start at the end. We can start all the way at the end here. So we'll line this up with this. We'll go 1, 1, 2, 3, and then 1. That way we can do a rail connector here, a rail connector here, and still have a 3-tile gap in between. And yeah, we know the routine. I'll construct this tower of fabricators and meet you on the other side. Okay, there's 24 fabricators for calcite sheets. Now we'll need to run probably a number of rails of calcium blocks down to feed these, so let's do some math on this. Let's take a look at the recipe. We're making calcite sheets. Calcite sheets consume 1 calcium block every 2 seconds. So that's 30 items per minute. So these 24 fabricators are consuming a total of 720 calcium blocks per minute. So we'll need to split this up into 2 separate rails. So let's see. That means we can run 16 fabricators off of a single rail V3. So we'll section off 16 of these 24 fabricators. We said what this is 1, 2, 3, 4, 5, 6, 7, 8. We'll take the bottom 2 rows. That'll be 16, 8 and 16. And then the top row can be fed by a separate rail. So our output from our calcium blocks will be coming from here. We're going to take this first one here and dedicate this to these bottom 2 rows here. So we should bring this down to the floor and then hook this up to probably here. So let's go down to here. So take this down to here, potentially. That's allowed. Just make sure we don't interfere with our ability to get anything else down here. So we'll go straight across into here. And then we'll feed this in this direction. There's 16. And then we'll be taking 1 output from this storage depot into here. Like this, most likely. And we'll feed these straight across. There we go. So for output on these fabricators, we're turning 1 calcium block into 2 calcite sheets. So 2 every 2 seconds is 60. So we'll have to do this in more subdivided rails on the output side, because that means we can only fit 8 machines per rail V3. So each one of these rows is 8, so each one of these will be its own output bus, feeding in probably in this direction. Although we do need to put a stack of furnaces in as well. We need 28 furnaces, and I don't think we're going to be able to fit 28 furnaces in this location here, because that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9 stacks. We're not going to fit 9 stacks in here, I don't think. Yeah, we're not going to fit 9 of these in here. So we'll probably have to do another stack down here for our furnaces, so we'll probably have some room here to put our storage for our calcite sheets. So all these calcite sheets are for synthetic resin, which is going to be way down the line. Now maybe we do want to move these over to this end and get them out of the center of this, where there's going to be more going on for production in this tier. So let's do that. We'll take our output and we'll send it to the left. like so. Let's go ahead and set the recipe on all of these machines if we haven't already. Calcite sheets, and there we go. So we'll wait for all of these calcium blocks to trickle in. Make sure everything is running. Except for the ones down here that are already backed up because they were running early. Beautiful. Alright, while those grind away on calcite sheets, we can start setting up our furnaces for calcium powder. We're going to run these in this direction. We're going to leave a gap of 1, 1, 2, 3, 1. We're going to do the same layout we did for Wolfram powder. 1, 2, 1, 2, 1, 2, 1, 2. So that's 8, right? 2, 4, 6, 8, and we know we need 9 of these to get us to 28. So we'll have 8, 16, 24, then 25, 26, 27, and then actually one more all on its own here on the bottom floor. And our pillar pattern for this was on the ground floor for level 2, and then raised all the way up for level 3. So like this. So we'll repeat this. There we go. 28 furnaces for calcium powder. Hook up some rails. The sound of these rails connecting is starting to become grating. It's like a hammer hitting my head every time it clinks in. I've done this hundreds and hundreds of times today. Okay, that's all of our furnaces wired up, so we'll need to get a string of calcium blocks over here. I'm going to calculate how many of these furnaces we can run off of a single V3 rail. So let's take a look at the recipe. Calcium powder, so we're consuming 1 block, and we're producing 3 every 3 seconds. So that means each one of these furnaces is consuming 20 calcium blocks per minute. So that means we can fit 24 of our 28 furnaces on a single V3 rail. We need to section off, I guess, these last 4 here. I guess we can zigzag it up here. So we'll run these 24 off of one V3 rail and these 4 off of another. The output of this storage unit, this storage depot, is already fully accounted for. The output of this storage depot is not. This is just using this top row here. So we're only using, I think, based on the number that we have hooked up here, I'm guessing that we're using 240 of our 480 out of this. And then we have this one here, 8 times 60. So this should be a full 480 here. We need to make a small adjustment to how we're wiring up our calcium consuming things here. I did not remember that this storage unit here is actually only pulling from 1, 2, 3, 4, 5 smelters. So this is not receiving a full 480 items per minute, but we are hooking it up to 480 items of demand. So we actually need to pull this down, hopefully without breaking everything again. There we go. We need to hook these smelters up to this unit, which is pulling from a full 8 smelters and is receiving 480. We need to get this down to here, which is not allowed. What it will be if I put a proper rail connector on it. So we'll run this into here, and then this down to here. I think that should work. So this 480 is accounted for. We'll take this down, because this should also have a full 480. This is receiving 1, 2, 3, 4, 5, 6, 7, 8 smelters worth. So that should be 480. And then this feeds this direction. This comes out to here. Okay, so this we need to feed over to our stack of these here, and then the output of this is going to be split between this and these 4 furnaces here. So let's figure out how we're going to get this all the way down to here without interrupting this rail here. That can go there. That works. Then we need to bring this over to... Uh-oh. I left too much space. How did I mess that up? Oh well, we have extra space. So we'll go to here. We'll bring this to here. And we'll bring this down this way. And loop this up here. So there's all of our inputs into our primary stack. Now let's get these 4 furnaces hooked up to the rest of the output from this guy here. We'll also need to bring this, let's say, from here to here. I'm thinking we hang a rail connector off the edge of the top row here. And then we can fly this... this is actually not right. I mean, it will work, but that's not the way that I think it should be done. So we'll take this out of here. And we'll take this into here. String this across to here. And then we can walk this down. Like that. And that should get everybody hooked up. So these fabricators, 8 fabricators, are consuming 240 items per minute. So between these fabricators and these furnaces, we're consuming 320. We need to see how much we have available over here. It's 300. That is not enough. How do we not have enough calcium available? We were told to install 21 smelters. So this is technically not enough to supply all of these fabricators and all of these furnaces running at 100% capacity, but with the downstream demands, we don't actually need 100% efficiency out of one of each of these machines. Because you only need technically 23.1 fabricators to produce enough calcite sheets, so one of these 8 fabricators in this row is only ever going to be running 10% of the time. And likewise, one of these furnaces is only running at 27.9%, so we don't actually need all 28 running at 100% efficiency. One of these furnaces is going to be running at 90% efficiency. So between this running at 10% and this running at 90%, that should make up the difference in the available calcium blocks based on their calculation here in Rupture Planner, I'm guessing. Hopefully that is correct. Because we have, at the very least, we have the 2 full 480 storage depots hooked up to the 2 full 480 strings of fabricators and furnaces. But I think this should be fine. So let's set all of our recipes here. Calcite powder, or calcium powder. So that should take care of all of our calcium creations. This is all of our calcite sheet furnaces and all of our calcium powder furnaces. And in fact, with this stack of 28 furnaces online, this is actually the largest creation or the largest stack of manufacturing that we still need to create, because everything else is smaller than this. There's only 3 more, really, that are going to be somewhat difficult. We have tube production, we have glass production, and we have chemical production. But none of those are going to require quite as many buildings as we have here. So things are quickly beginning to fall into place, and with just a couple more speed bumps here, we should be pretty smooth sailing to wrap this up, because the high-level buildings are relatively low in numbers, so those should come online relatively quickly as long as we can get the output of all of these gigantic stacks into them. So next, I guess we'll take a look at some of our combination manufacturing. So these will be the first ones that are going to take 2 different materials as their inputs. So I guess we'll start with titanium housings, because that can all be contained in the titanium section. We're going to need 3 furnaces operating titanium housings, relatively painless. We just need to figure out where we want to put those. So titanium is here. And those are taking sheets and beams. And our beams, we put somewhere... Our beams are right here, if I remember correctly. We need to get our beams out of here and combine them with our titanium sheets, which are being manufactured right here, I believe. So let's figure out how we're going to get... Well, let's just put the furnaces down, and then that'll dictate how we run our rails. So furnace, like this, so that we can do flat, flat, then fully extended, then 2 and 3. 1, 2, 3, 1, 2, 3. Platform here, then furnaces here and here. There we go. There's our 3 furnaces for titanium housings. Now we need to get 2 different materials into this, and I guess we'll do just kind of a vertical cascade here. Well, that should be fine. It'll be a little bit ugly, but we can do something like this. Input. Then we can come up around the sides. Input. And then come up around like this. Actually, we don't even need this. We can get this out of here. Straight into there, like that. And we can bring plates and beams into the front. And out of the back here, we'll just cascade back down. We do something like this, out to the side. Bring this into here. Bring this into here. And there we go. We'll leave that there until we figure out where we're bringing these housings. Now we need to get our sheets and our beams into here. We need to get this across here somehow, which we can do with a rail connector raised up to go over the top of this. We'll raise this all the way up. Here comes the spaghetti. We're gonna go up. We'll go over. And then we can come down really anywhere we want. We'll do it in line with this. And here. We'll go all the way up. Then we'll go down from here to here. Across from here to... Colliding with another building. What? No, go into there. Thank you. Okay. There's beams, and then plates. Plates are used in tubes, housings, and then they go up here to heat-resistant sheets. So we probably should feed these into a storage depot somewhere. 1, 2, 3. pillar support. I'm gonna put this storage depot here. And where are... I think our outputs are here and here, right? Or this just feeds into this, and then we have this. So we'll take this here. Let's take this here. And then this here. So there's 2 rails, which will definitely total less than 960, because we're only producing 864. So we'll set this to titanium sheets. Our titanium housings and our heat-resistant sheets will have to come off of the same output from this, and then the other output will be dedicated to tube production. So we need to split this a few ways. So we'll take a rail connector out of the backside. Connect this into here. And then we're going to send one off in this direction for production of titanium housings. We need to get this through this stack somehow. Like this, perhaps? Let's do... Yeah, we'll do it like that. We'll feed this through to here. And we can feed... I guess we can just do this in the back here. It doesn't need to come into the front. So that should get these online. So while this is filling up with plates, we'll set recipes in here. Titanium housing. And titanium housing. Here it comes. Worming its way up the stack. And we're producing housings. Okay. On to the next thing. Tubes. We need 21 fabs for tubes. 21 fabs for tubes divided by 3 is going to be 7 stacks of fabricators. Can we fit that right here? We may need to move this rail here, depending on how many we can squeeze in here. If there's one here, this will be 1, 2, space, 3, 4, space, 5, 6, yeah. We can technically do it. It's gonna make this little passage here kind of tight, but we can squeeze this in here. So 1, 2, 3, 4, 5, 6, 7 times 3. This will give us our tube manufacturing. Let's see, move this to here. Can we pass a rail from here to here? We can. So we can do this. Get rid of this. And let's see, can we bring this rail, instead of bringing it into here, can we bring it into here? We can. Okay. That solves that problem. Get this out of the way. Okay. That's 7 times 3. That's 21 fabricators for tubes. Let's hook up rail connectors. Okay, there's all of our rail connectors. Let's get our rails connected. What is this connected to? Try that again. Okay, there's all of our rails hooked up. So, now let's figure out how we're getting our... I messed up. I messed up! I need 2 rails of input. I guess we're gonna be running them from this side, right? So let's go... like that. Hook these up on the left. And we'll put our rail connector for the other item directly adjacent. Run this rail through. And put these on the right connector. I did not look at our ratios. Let's look at that real quick. So we have 7 connected, right? It's 7, 7, and 7. Starting here. 1, 2, 3, 4, 5, 6. What? Am I dumb? 1, 2, 3, 4, 5, 6. Oh, this is also it. Okay. Bring this in here and bring this like that. There we go. So, 7 fabricators producing tubes. These are consuming 1 of each every 2 seconds. So that is 30 per minute of each of these materials. So that means that each one of these rails, 480 divided by 30, can support 16 fabricators, of which we have 21. So that makes splitting this a little interesting. So we'll have 7 along the bottom, and then an additional, what, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we'll have 2 rows. That gives us 14, and then 2 more from the top row on 1 string, and then the additional on another string. This will go in here. This will go in here, and then I just need to figure out how to get this up here like that, I suppose, and feed this back this way. There we go. That's 7, 14, 15, 16 buildings, 16 fabricators wired up on 1 pair of strings. And then we have another 1, 2, 3, 4, 5 to wire up from a different rail. And let's just have to go wherever they are allowed to anchor. So 1 here, 1 here, 1 here, and 1 here. And that will dictate how we're stringing our input rails. And by that I mean, here we'll have to go bottom to the left, top to the right. Here we'll have to go bottom to the right, top to the left, like that. Now those 5 are wired up. We need to get a full 480 rail of plates into here. Let's do it to here. And then the other section of this is going to share from this rail connector here. Ooh, that worked out perfect. Look at that. Okay, great. And then the only other thing that we need to get off of this is a very small amount of these for heat-resistant sheets. I think this will work out just fine, well, even though it's looking a bit noodly. So now we need to get titanium rods into this connector here and this connector here. Titanium rods, we're gonna have to do a little hunting here. Aren't these titanium rods on the outside here? They are, okay. So we need 624 of these rods per minute going into our tube production here. That's going to be divided between, I'm sure, a 480 for this bottom pair of rows, and then everything else for this top set here. Rail connector here. Like that, and then we'll run this right. No, that's okay, because we can do this. We can bring another one up here. We can bring this out of here into here, just like down below. And then we can loop this up like this. That will supply this bottom rail here, this bottom rail here. And then we need one more partial connection We're receiving 2 inputs into here, right? Yeah, so we have more to give from here. 480 plus 180 is 660. It's a little bit more than we need. That's okay. Because we can always split this another way. We'll take the rest of this out of here. That way we have another dedicated 480 rail down below. That should be more than enough than we need to cover the production of these tubes. Oh god, I'm getting kidnapped. Oh, I'm getting pushed off. Stop. There we go. Alright, let me set all these recipes. Now, we're not getting plates. Let's break this here. And put a rail connector here. And then we can do one out into here. And then one out into here. There we go. These are full. Okay, we're fully manufactured on tubes all throughout here. And for tubes, we're producing 2 every 2 seconds, which is 60 per second. So we can fit 8 of these fabricators on an output rail. So we have 7, 7, and 7, so we're gonna have to do all of 1 row, then 1. And all of 1 row and 1, and then another 5. We can take 1 from here and give it to row 1. We can take 1 from here and give it to row 2. So now there's 8 at the end of each of those rows, and then we'll take the remaining 5 and pass them down to the end. Then we have 480, 480, and 300. Well, these ratios are getting a little hard to track, but we're making good progress. Let me get turn the UI off so we can get a better look at this. Absolutely a ridiculous number of buildings. Good grief. Next we need 14 fabricators for rotors, which are going to take more rods. So we'll have from here, what, 3, 6, 9, 12, and 13, 14. We should look at our ratios first, so that I know how many of these need to be strung together. So we're making rotors. So we're taking 2 and 2 every 6 seconds. So each one of these is consuming 20 per minute of each item, or on each rail for each item. So if we divide 480 by 20, we can fit 24 of these on a single 480 item rail, which means we can fit all of them because we only have 14. So we are saved by a long construction time. So let me set up our rail connectors. Okay, there's all of our inputs wired into our fabricators, and we know that all these fabricators will run on 1 V3 rail each, so we just need to connect Wolfram wire and titanium rods into probably here, and then we can loop these up to here, and then loop these up to here, and then all these will be sent this way. So for that we will need, I think, a set of connectors here and here, because if we want to loop these up like this, no, we can't do that with this. I always forget that. Here. So we'll see if we need this one at all. We need to get our wire and our rods into this connector and this connector. And then real quick before I forget, let's run this up to here. Run this to here. We'll run this to here. There we go. Now it'll cascade up. So it'll go from here to here, then from here to here, and everything will run to the right. So let's find all of our parts here. So we have our rods are right here. That seems easy enough. Suspiciously easy even. So if we feed this into here, and then we go from here to here. We can. Okay, so if we go from here to here, there we go. And then our Wolfram wire. So I guess these just kind of come to the end here and stop. So I guess we can run these up into here. Because these have to go a few different ways. We need these for stators. We need these for rotors. We need these for inductors. We'll set this to Wolfram wire. Slurp all this up. Let me need to get this all the way over to here somehow. I'm gonna string some rails here. You've still not done anything with all this Wolfram powder back here. Let's see what we can do. Luckily, we only need one rail V3 for this. We'll put a rail conductor, a rail connector. Right here. Auto-saving. And from here, we can string this to... I think this is going to be... We go from here to here. And we can go from here to here. I think I'm going to take this just down to floor level here. We'll bring this to here, and then down into here. And that should get... There they come. Our wire flows. Okay, let's hitch a ride here. Oh. Come back! How dare you. Alright, we'll set all these to Wolfram wire. No, not Wolfram wire. What am I doing? Rotors. Okay, and here's all of our materials flowing in to produce our rotors. Majestically zigzagging up the floors. Bringing all of our fabricators online. Beautiful. I'm going to finish wiring up the back of these. And let's take a look at our ratios here. So we're producing one rotor every 6 seconds. That's 10 items per minute. And we have 14 of these, so we're producing 140 items per minute, which means we can most definitely fit all of these onto a single rail V3. So we'll connect all these outputs together down to probably the bottom here. And this will be complete. All right, here we go. Our output rail with 140 rotors per minute. Take a quick look at where we're at. We have mostly filled up this crater. It's kind of hard to see with the all the smoke about, but we've only got room for maybe 2 more rows of construction here, and then we're gonna have to start getting creative on how we squeeze this stuff in around the outside, because I want to put as much of this in here as possible. Because I want it all to fit in one gigantic, ludicrous screenshot, just so we can see just how ridiculous the exponential nature of this game is. And that all of this machinery is all to feed one single machine to produce one item every 10 seconds. So yeah, we're getting there, but for right now I'm going to take a little break because I'm getting a little exhausted putting this all together. Okay, I'm back from my break, and by quick break I meant I'm going to bed. So it's the next day. We're gonna pick up where we left off with, I guess, ceramics. Ceramics are gonna take calcite sheets and wolfram powder. So we're gonna build this somewhere over on this side of the crater, where these things are located. Let's see, so wolfram powder is all the way in the back. Can't even see it from here. It's this furnace stack all the way in the back here. And calcite sheets, I want to say, is right here. This is calcium blocks. So, how many of these we need? We need 15 of these. So that's 5 stacks of 3. I'm gonna have some room back here for that. Let's see. We need to be able to place 5 of these in a straight line. Here, 1, 2, 3, 4, 5. That works. And our output from our wolfram powder furnaces are right here, so we'll be able to feed that directly into our ceramics line here. And there we go. Okay, so we have just enough room here to work our 2 input rails without touching this stack here. Now we will have this, but we're gonna get rid of this. This was just a marker, so we knew where our outputs were. Most of those are going to chemicals. Let's do our input rails. Let's check our recipe on ceramics. So we need 1 wolfram powder every 2 seconds. 30 per minute. So 15 times 30. We need 450. Which will fit on a single rail. So we can wire all these together. We just need to get a full, well, a mostly full rail of wolfram powder into this. So let's take a look. I need a partial output of a 6th machine in here. So I actually need a string with 6 of these. And I kind of want to take this section at the bottom here that's buried in here, because it's going to be hard to get this out of here. I'll take one of these off of here. I'm going to add this machine into this string here. That'll give us 6. And I'm gonna run this into here. There we go. So now we have 6 machines running into this whole stack here, right? 1, 2, 3, 4, 5, 6. So I can build our second row of rails. Wire these up. There we go. Now for row 2. Okay. And row 3. There it is. It's way up there. And then how are we getting this up here? Oh, here we go. Actually, we can just go off of here, right? If this comes up, whoop, comes up here, spits out this way, and then we can come from here up to here. I just need to delete this. And this. Feed that way. Then we can put this back. And if we put one... we don't have a pillar here. Pillar, pillar, pillar. And then we can go from here to here. And from here to here. There we go. And then we just bring this up to here. And we're golden. Alright, so let's feed these in. And my game just crashed. No! Creepy jar, why? Okay. We've rebuilt. And I believe this comes down into here. This runs this way. This comes up here, goes this way and this way. Okay, I think we're ready. We've got all of our inputs hooked up. I'm going to save now. Okay, now we need to get our calcite sheets from here. Maybe down this row and to the left? We'll figure it out. Why do these not have tubes? There they go. At any rate, calcite sheets. Output to here. Okay, so we're gonna put a storage depot for calcite sheets. Right here. Another one. Right here. And then we're gonna connect 2 of our stacks here to this bottom one. So one here. And then from here to here, like that. Okay. This should be 2 480 item rails into this bottom storage depot. And this should be 240 here on the top. This will go into this way. So I'll set both of these to calcite sheets. Because we have to take some odd numbers of items per minute out of this to feed all the things that calcite sheets need to go to. And it's going to be easy to balance if they're coming from a central source. We're going to take 429 items per minute from our bottom storage container and bring this over to our back row of furnaces over here. Okay. Then one here. Bring this down and into this, right? And that should be that. So this should bring our calcite sheets over here. A bit of a hike. Okay, let's set our recipes. Ceramics. Okay. And I think I want to have a local buffer. Not a full-size storage depot, but just a small V1 depot. Just to reduce the amount of travel that these calcite sheets have to take to get over here. Otherwise, we may hit a situation where a furnace would otherwise be operating efficiently if it was getting its inputs in time. So it's sent out the request for the inputs at the right time, but it takes so long for the calcite sheets to get here that's actually running out before it receives its requested sheets. I'm going to break this. I'm going to put a storage depot V1 right here. And then we'll go from here to here. And then here to here. Where am I? I'm right here. I'm going to set this to calcite sheets. We'll drop in these 10 that we have here. There we go. Take the whole rail. Drag these into here. Take all. What? They're gone again. What is happening? Oh, I get... Yeah, they're gone because the machines are eating them. Pay attention, genius. Okay, everything's flowing now. We're good. We're golden. And we're producing ceramics. Beautiful. Now, we'll just set up the output rails. Okay, let's take a look at our output ratios here. So we're making 2 every 2 seconds. That's 60 per minute, which means we can fit 8 of these per string. So... now we have 5 per row, 5, so we'll do 6, 7, 8, and then 5, 6, 7. 6, 7, well, let's do 6, 7, 8 with these 5, and we'll bring these down here so that our outputs are these 2 at the end to make it easier to get into here. Feed this into here, feed this into there, and then bring this guy into there. Perfect. We'll set this for ceramics. And they're gonna unload one at a time. Interestingly, I think, didn't these have their own, since they have their own independent rail into here, they should also be delivering at the same time, shouldn't they? No, they're not getting Wolfram powder. Why are they not getting Wolfram powder? Oh, what did I do here? Why does this have double... no, that goes up to the top. Huh? Oh, this doesn't go here. This goes here. There we go. That makes more sense. I'm confused about how this rail's working. We have a demand available for these ceramics. You fully unloaded. You're stuck at 50. Why don't you just put more onto the rail? The rail's not fully loaded. This guy won't deliver anything. You come out here, you go to the right. And this guy refuses to go below 49. Even though there's plenty of rail capacity available. No, maybe I will do these on separate storage units, storage depots. Let's delete this. Build storage depot V2 way up here. Up in the sky. Alright, let's grab these blocked. Those are flowing. And these should unload one at a time. So we're good. So let's move on to... I wonder if we should do... maybe glass next? Glass is going to be one of our last two remaining big constructions. We're going to need 23 furnaces for making glass. So let's see where we have room for 23 furnaces. We are overheated here in... this, okay. So we'll slap a couple more base core amplifiers on this. There we go. So 23 divided by 3. These are gonna need 8 stacks. Well, 7.6 stacks. But one will have 2 furnaces instead of 3 furnaces. We'll put these here. Let's align this. Uh-oh. Uh-oh. Here they come. Hey. No. Okay, so 1, 2... 3, 4, 5, 6, 7, 8. Like that. Okay, let's double check our work. So we have 8, 16, 17, 18, 19, 20, 21, 22, 23 furnaces. Oh, again! I just killed you guys. And for making glass, these guys want 2 calcium powder every 3 seconds. So that's 60 divided by 3 is 20. 20 times 2 is 40. So we're gonna need 40 calcium powder per minute into each one of these machines. We can feed 12 of these machines off a fully loaded 480 item rail. And we have 8, 9, 10, 11, 12. So if we do something like this, we hook up these bottom 8 together, and we loop this up top into 8, 9, 10, 11, 12. We grab these 4 as well on this one string, and we can bring this row of calcium powder furnaces directly into here. And then these machines will be consuming all of this output. So we don't even need to bring this into a storage depot. Bring that there. There we go. Now our helium is another story. Our helium is over here. We'll probably be bringing our helium in from this direction. So we'll need to run this line in the opposite direction. I've not checked our ratios, but I assume we can fit at least 8 on here. Let's see. Which machine do we have set up? This one? Yeah, we're consuming 1 instead of 2, so we can definitely fit more than 8 machines on our helium string. We can fit 16 machines on 1 string of helium, because we're using half as much as calcium powder. So I have no problem setting this up like this, and we'll bring our helium into here. And let's go figure out how we're going to bring our helium in here. Okay, so our rear 2, each one of these helium extractors is producing 240 items per minute. So these 2 are combined into a single 480 rail, which is available on the left here. So let's get this wrapped around our crater here. So right there. So here. Alright, we're gonna put a storage depot here. Wrap this into here. Wrap this into here. And then connect this to right here. And that should give us access to helium with a little bit of a local storage buffer here to reduce the call distance. We'll wait for this to come pouring in. Here it comes. In and then out, and then we should be making glass here. Yep. So this is one of our 2 strings of furnace glass furnaces. So now we need to get our partial set, because this is 12. And we have another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to hook up. So for helium, we have what, 8? We have 16 on these 2 rows, and a line of 480 helium, a fully loaded V3 rail can support up to 16 of these. So we'll split our calcium, because the calcium demand is higher, but we can continue our helium 3 line through this entire 2 bottom rows here. 480 divided by 20. 24, no. So the demand for helium 3 is 1 every 3 seconds, which is 20 per minute. So 480 divided by 20 is 24, so we can actually run all 23 of these off of our 1 incoming helium 3 line here. So we'll do that. We'll continue this helium 3 line all the way through, and then we'll just need to split off the remaining 11 furnaces to some calcium powder furnaces here. But we'll worry about that in just a minute. So we have a demand of 440 calcium powder for 11 glass furnaces, which is almost, but not quite, of another full rail of calcium powder. So if we take another 8, 1, 2, 3, 4, 5, 6, 7, 8, just like this, feed them over here, feed these across to here, and then we need to get this up to this top row here. Can I do it from here? From here to here? That works. That's much easier. Okay. So that's all of our calcium powder supplied. That's all of our helium supplied. So let's set our recipes, and we should have all of these furnaces making glass. There we go. Let's step back and observe our handiwork. I see green lights everywhere. Okay, and with glass up and running, I think I'm going to take another little break here before we move on to either synthetic silicon or maybe stabilizers, but we'll figure that out when we get back. With the remaining space that we have here, the remaining open space, let's take a look here. A bird's eye view. We've got some space over here. I left this rail, I put this in between the lanes here, or I guess in the lane between the two stacks here, so that we have some space on the back here. We can build over these Wolfram deposits. Then we have space here, and in this space we need to fit at least one more big stack. And our only other large stack, like over 15 buildings, is furnaces for chemicals. Chemicals are going to take synthetic silicon, though, which we do not have online yet. So we're going to need to do that first. That's going to be 13 furnaces. So I'm thinking maybe we do synthetic silicon here. And then we have this back row to fit in our 19 furnaces for chemicals. And then everything else should be around 10 buildings, which will be a lot easier to squeeze into smaller flat spaces. So let's do synthetic silicon next. Let's line this up here. So 13, what's what, 3, 6, 9, then 12. So we're gonna need 4 stacks and a single one. Then we do our single one here, input on that side, lock our Y, and then we'll do a space, and then we'll do 2 here. So this will be 3, 6, outside. Oh, right, I need to move that base core forward a bit. We have a tiny little section, a little square here. This little square here where we can't build, so I need to move that forward. Looks like maybe 10 tiles. There we go. Okay, I'm gonna say 3, 6, 9, 12, and then our extra one here will be 13. So this will be our layout for this tower. What is this? Okay, well, for some reason, you don't seem to be able to build a pillar on top of a pillar over a resource node. So I can't actually put a second tier here, but I can put a third tier on this. So what I'll do is I'll just move the furnace that was in this position, or should be in this position, and we'll stick it on top of this guy here. So we still have the same number of furnaces, just in a dumber arrangement. Like so. So we should have 13 furnaces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 furnaces. So this is actually going to look like this. We're going to have a lower rail here. Calcium powder. Calcium powder is right here. So this will probably end up running this direction. Like this. And we'll have a rail connector on top of that. In the middle here. Ceramics and helium are both going to be coming from this side, so I think these other 2 rails will be running to the right. So these will go this way. Like that. And then we'll have a third set of rail connectors. Running like so. There we go. And then each of these is going to have one of these 3 inputs. Like this. Like that. And then we'll repeat this for row 2 and row 3. Then we'll figure out how we're going to get all these items into here and split between these 3 rows. But first, let's look at our ratios. So we're going to be making synthetic silicon here. This is going to be consuming 2, 1, and 2 at every 2 seconds. So this is going to be times 30. So this is 60 calcium per minute, 30 helium-3 per minute, and 60 ceramics per minute. So if we multiply that by 13 machines, that gives us 780 powder per minute, 390 helium-3 per minute, and 780 ceramics per minute. So we're going to have to split this into 2 sets of furnaces, at least for powder and ceramics. So we can fit 8 machines on one V3 rail for powder and ceramics. So we'll split 13 into 8 and 5. This would have been so much easier if this was here, because then we just take 2 rows. Because now we have to do like 5, 6, 7, 8, and there's 1 left down here that we have to get another set of these into. Whatever, we'll make it work. 1, 2, 3, 4, 5, 6, 7, 8. So we'll take these 8 calcium powder furnaces, and we're going to feed this down into this bottom connector here. Let's take this into here, maybe? Go from here straight down into this. That works. And then we can route this, you know. Can I do something really funny? Can I delete this? Can I put this all the way down and still have this work? Will this connect to this? It will. Alright, watch this. We're gonna delete these 2. We're gonna put a rail connector right here, all the way down. We're gonna run this from here to here, and then from here to here. And then we're gonna put these rail connectors back in. It's like we were never here, but we do need to now clearly set up another remote power plant. So we have one power facility over here. I guess we'll set up another power facility over here now. You just need to make sure that it's out of the range of the edge of this, because I'm assuming we're going to wind up using all of this area around here. So this needs to go kind of far out, maybe over in that direction. Let me go do that so we can get some more power fed in here. Alright, we'll connect this up to our existing power base here, and now we have a further power base here in the distance, which you get over the tree line here. There we go, right on top of the mountain there, staring right at the sun. This will feed through our existing transmission line down into the main assembly crater. Okay, so back to this. We have 1, 2, 3, 4, 5 of these furnaces currently being fed with powder. And we can feed up to 8, right? Because each of these is producing 3 every 3 seconds, which is 60 per minute, which is the exact consumption. This is 3 every 3. This is consuming 2 every 2 for synthetic silicon. 2 every 2, which is also 60 seconds, which is also 60 per minute. So we need to get this rail also up to here for these 3. So I'm gonna put a rail connector here. Drop it all the way down. 3, which is 6, 7, 8. We need to find a way to connect this or this to this. Or this. This works. And then this can connect down to here. There we go. Problem solved. So this will run this way. There's 6, this is 7, and this is 8. We'll connect these up. And I think before we should continue, we should figure out how we're getting our ceramics and our helium in here. Let's go take a look at our helium base. So in our remote helium base, we have 3 more helium extractors. with 2 combined onto the left rail here for 480, and then 1 on its own for 240. So we want to connect these 3, well, I guess technically these 4 dispatchers to a set of receivers on the rim of our main assembly area that we can then feed a full 480 rail into our silicon production. So let's get that set up next. Cargo receiver. And we only need 1 of these. We only need 1 of these, so I can stick this right here. And we can feed the output of this into, say, this middle rail here. And we'll call this ASMB Helium 3RX1. Alright, let's go link our dispatchers to this receiver. Okay, we're accepting Helium 3. We're dispatching to RX1. Helium 3, RX1. Helium 3, RX1. And our supplementary dispatcher to RX1. Okay. Alright, and there's our Helium 3. So, we have another 240 available over here that we need to bring over for our...
Oh, I needed that.
Actually, you know what? No, because this 480 rail is enough to feed all of these. So we have another 240 over here for something else that uses Helium 3. Escapes me at the moment. But this we can loop through the entire stack here. We need to get this up to... I did that wrong. Uh-oh. Redo. That's okay. We didn't really lose much. We're gonna bring this all the way down. It's gonna go this way. It's going to be a regular rail connector, regular height rail connector here. Running probably that way. Because we can just go from here straight to here. That's not a big deal. And then this way, and this way. And then we need to reconnect this now to this, and of course we can't. Of course we can't. Let's see. That's fine. As long as it doesn't prevent us from putting this here, which it does not. We're golden. Okay. So this will go in here. This will go in here. This will go in here. And that'll go in there. So, our last piece of the puzzle to get in here is ceramics. And ceramics are all the way in the back. Let's run over there and see how we can get these on the other side of the assembly crater. Alright, what I'll probably do is put a rail connector here. Let me just make sure I can get this from here to here without hitting this rock. I can. Okay, and I'm going to string another rail going back around the outside rim of the crater over to that corner. And then we'll have to put another, like just a V1 storage depot there as a local buffer so that we're not, the machine over here is not asking for a ceramic and then having to wait 30 seconds while it makes its round trip around the crater. So, let's hang that storage depot. Off the side here. So we'll bring this to right here. Like that. Then like that. And then like this. That's allowed. Incredible. We just need to set this to ceramics, and we're on our way. For at least half of these furnaces, and we're gonna need another 300 right? 780 minus 480. Another 300 powder and another 300 ceramics to feed the other half of this stack here. And they've arrived. And, oh yeah, we did set one of these. Okay. So, let's get 300 more ceramics over here and 300 more powder over here. Okay, I mathed it out, and our calcium powder production, according to the plan set out by Rupture Planner, is actually producing 20 less calcium powder than what's required to run all of our glass furnaces and all of our silicon furnaces. So I can only assume that that 20 calcium difference is going to be because either one or both of these sets of furnaces are not running at 100% capacity at all times. So what I'm going to do is we're going to run these 4 calcium powder furnaces into our remaining silicon furnaces here, and I'm going to split off 1 smelter somehow. 1 calcium powder furnace, because this runs this way, so the only thing that'll get into this loop here is this one machine here. So we'll split off a bit of this, because this loop here is actually not running at full capacity on the 11 furnaces that we have here for glass. So we'll grab some of this and these 4 and feed this into our remaining furnaces here. And we'll just trust the system, we'll trust the plan that the ratios are correct here. So let me loop all these together and then run this into this set of furnaces here. You know, I think this will be less annoying if I take this out of here and put it up here instead. Because getting it to drop down a row is way more annoying than just continuing it over here. Okay, there's 2 of our 3 materials in. Our heliums run through, our calciums run through. I had to do a little creative support work here. Now we run into 2 issues. One, the pillar supports here are at the centers and not the edges, so you actually can't place 3 rail supports in front of our furnaces here. They're just not, the support is too far away. But it builds supports here to put 3 rail connectors across the front of these. Then we also ran into the issue that this is the first 3rd story furnace we've done with this 3 rail configuration, and having this maximum height rail is actually causing these lowest height rails to be invalid to place here, because there's actually a 1 tile height difference between the 2nd and 3rd row. You can see this furnace runs right up against the ceiling here versus the 1st and 2nd row. You can see there's a gap in here. So these rail supports are actually 1 tile closer to these rail supports, and that makes us unable to place these in the lowest position. So I had to raise all of these by 1. So we can place these 2, but we can't place a maximum height rail here. Well, no, we can't, because if we were to try to put this here and run this all the way up, this needs to be 1 position higher than its maximum height in order for this rail to pass through its center point. So we can't place this here, but we can just place it back 1 position like we normally would if we weren't abusing a rail placement bug here for this. So we'll pull this back 1 and place it something like here at a higher height, and then run this into each one of these. So we'll get this in here. So this needs to have a separate line of ceramics, right? Because I'm pretty sure we're maxing out this line of ceramics. Now let me go and run a second partial line of ceramics. Let me see, let me calculate exactly what we're going to need here. 5 times 60 is 300. Okay, so we need 300. We need a rail of 300 ceramics coming in here. Go from there to there, there to there, and we'll just run these. No. These backwards. So we'll pop out of here, go to here. Run this backwards. There. So, if I set this depot to ceramics, here they come. That's exactly why we're doing local buffering here. Here they come. Meow. Okay, so these will feed backwards to these 5. Everybody else down here has everything they need, right? And then our helium is bouncing from here up into here to feed this line. I think we might be ready. Let's set our recipes here. Synthetic silicon. Here we go. That's flowing out. I see stuff flowing up over here. Zooming down this line, clipping through our rail supports. Oops, I just stole a calcium powder. And give that back. Synthetic silicon. Okay, let's take a look at what we've done here. That one was a bit of a mess. We had a couple of issues throw us off here, but we managed to get around all of them, and I think everything is good now. We have parts flying into all of our machines. I don't see any yellow lights, well, except for the one that's was already functioning and backed up. So yeah, all of these are looking good. So there are our, what, 13? What do we have here? Our 13 furnaces manufacturing synthetic silicon. All right, time for another break. Okay, next up, we need to take a little step back in time through the tech tree, because we have to set up some fabricators for stabilizers and for stators. We're going to need 11 fabricators for stabilizers and 2 for stators. So 11 times, or well, 11 divided by 3, we're going to need 3 stacks of 3, and then another 2. 1, 2. Let's lock our Y. 1, 2. Building's not stable on this side. Now, I guess we could go 1, 2. If we do this, if we bring this up by 1, we'll have to put a new set of pillars here to support this, but it should be okay. So let's see if we can get away with this. I think this might be an issue, but we might have to get creative with getting our 3rd tier on here. Let's see what we can do. Okay, there we go. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't need 11. What happened here? 1, 2, 3, 4. Oh, I got so many extras. 1, 2, 3, 4. 11, 12, 13, 14. I went overboard. Well, I guess we'll keep these 2, because these 2 can do our stators, which you also need. So we'll do 4, 8, 9, 10, 11. We'll get rid of this guy here. We'll put a platform here. And I guess because these fall technically into this base core, well, we got some thermal issues here, so let's place a base core amplifier here. Everybody happy now?
Rotor activity detected.
Just in time.
Recommend finding a safe place.
We're about to find out if it worked. But yeah, this where do we put these? This will be our stacks here. So these 4, 8, 9, 10, 11, these will be for stabilizers. These 2 will be for stators, and then we'll work on getting their component materials over here as soon as this rupture's done. So we need 110, 1 rotor every 6 seconds times 11 is 110 rotors per second, and 2 rods every 6 seconds, which is 10, 20 times 11, so 220 rods per second. So we can fit both of those on a single rail. So we just need to get this connected up and distributed amongst all of these. We don't have to do any kind of fancy dividing of our inputs here, so a small mercy in this instance. Okay, there's all of our input rails wired up. I do want to locally buffer our titanium rods. I'm going to replace this line here, or this rail support here, with a storage depot V1. You were hitting me. Okay, so that'll go there. And then from here into here. Good. We'll set this to titanium rods. Buffer these locally right here. And then we need to get, this is stabilizers, right? So we need to get wire? Rotors. We need to get rotors into here. To here. And then we need to locally buffer this. Storage depot. Here. We'll put a rail. Here. To receive our rotors. From here, into here, out of the depot, into here. No, into here. There we go. And then we'll assign this to rotors. Here comes the train. All right. And they're flowing into there. Perfect. Now I just need to set recipes, and we should be good for... not rotors. Hurry. What are we making here? Stabilizers. Okay. I see fabricating. Perfect. Okay. Stabilizer production is stabilized. Pop over here. We're going to be producing stators. That's going to require titanium housings and Wolfram wire. Let's go track those down. If I break off, I guess, this back connector, and we come over here, it's almost perfectly in line into these two fabricators here for making stators. So let me get this passed over here. That'll work. And then how do we want to bring this down here? I guess we can just do this. We don't have to do anything special here. Right, and then we can do one into here, one into here, one into here, one into here, so we can go straight from this rail into here, and then loop this down into here. That takes care of our Wolfram wire, and then we need some titanium housings. Do we not have titanium housings set up? There's only 3. There's probably a single... is it this? Is it this single stack of fabricators? It's gotta be. Found them. Okay, I knew we were making them somewhere. So... these are looping out. Looping out. They're coming down. Luckily, they're not too far away from where they're needed. Let's take these out of here. And then from here into here would be perfect. Because then we can loop from here up into here. And there we go. And they're already off. Okay, so there's our 2 fabricators for, what are these? Stators. So let me slap some output connectors on these. And then we can move on to our last big speed bump, and that is chemicals. Alright, so chemicals. Chemicals need synthetic silicon, helium, and wolfram powder. And we need 19 of these. Getting that much wolfram powder over here is going to be a bit of a pain. Because the wolfram powder is actually at the far end of this. Way over here. And we need to get this probably over here. It's really the only place left that I have to place stuff. But luckily, this is the last really big batch of buildings that we need. So if we can make this fit, if we make 19 furnaces fit in here, we'll be in the home stretch. All right, 19 furnaces for chemicals. Now, granted, if we do another tri-stack, we're gonna have to do some funky stuff up top, because this is a 3-input recipe. I'm wondering if we should maybe at most double stack it. So 19 would be, what, 10 basically, with one extra. So 1, 2, space, 3, 4, space, 5, 6, space, 7, 8, space, 9, 10. Which is basically the remainder of our space here. We'll set up supported platforms. We only need one set, right?
I'm detecting
No.
increased Rotor activity. Prepare for a wave.
I'm not done yet. Furnaces, go. So we're at 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, let's go hide from the rupture. So I only have 240 out of that last helium extractor. But I have 480 right here, untouched. So let me do a little reorganizing here. We'll set up 3 cargo dispatchers. I'm going to set up a cargo receiver right here. I'm going to call this ASMB HE3RX2. Alright, we're going to accept helium-3. I'm going to send this to HE3RX2. 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 Can I run a 4th off of this? Do a little experimenty-wenty. Alright, so let's get connectors on. So we're gonna need 3 connectors on each of these. So we're gonna need to do this whole spiel again. So we're gonna do, I'm gonna split this into 2 sets of basically 10. We're gonna have 10 and 9. If we look at our ratios here, our requirements, our items, we're producing chemicals here. So every 2 seconds, this would be what, 30 synthetic silicon, 30 helium-3, and 90 Wolfram powder per minute. Where else is helium-3 used here? Nozzles. I use 12 per minute. We can pull that off of here, actually. So what I'm thinking, let me get rid of this. I have a receiver here, and I set up another helium extraction base at the same spot. If you watch my main playthrough, it's the same spot that we use helium in my main playthrough. It's not on this map, For whatever reason, they didn't get it on this map, but it is right here next to our Wolfram base. Right in this little gap right here, there's 2 helium nodes that I have going into a set of dispatchers. And those dispatchers are dispatching to here. So our goal is to get 480 into this. Then we only need 300 of it. Let's connect this to here, get this back into power. So that'll supply helium to this bottom row. And then we have another 240 available over here. Between the extra 180 from this row and the 240 that we have over here, that should give us enough to cover the other 300 that we're going to need up top here. Let me string this up, and we'll see if I'm correct. What? No. Stop. What was that magic? They went off this edge of the rail and then wound up in here. So then we can put our second set of rail connectors here. And this is going to be our synthetic silicon, which I think should be, well, glass we're also going to need here. Like this is synthetic silicon. No, this is Wolfram powder, isn't it? Chemicals. Wolfram powder, yeah. Where is our synth silicon? It's right here, okay. So we can take it, yeah, we're taking it over to this edge. So our synth silicon feed will also be from this direction. We'll run these likewise to the right. Okay, so we know we have a full 480 into here, right? If we take out of here and then string this around to this side, we should be looking good. And we'll go into here, and we crashed. Thank you, StarRupture. Here we go. Okay, and then the real challenge, getting... God, let me calculate this. This is going to be a lot. So it's, we need 90 per minute per furnace for 19 furnaces at 90 Wolfram powder a minute. That's 1,710 Wolfram powder per minute, which is like 4 separate V3 rails to bring all that Wolfram powder over here. So, that sucks. Okay, so here's my solution. I have a set of 6 rails that I've run all the way across the base over to where we're producing chemicals. So I'm going to put 5 furnaces each of Wolfram powder onto each rail, and then each rail will run over, it'll locally buffer in a V1 storage depot, and then it will feed 5 furnaces on the other side, producing chemicals. So we're going to take this first 5 here. 1, 2, 3, 4, 5. We're going to feed this somehow into here. That's fine. Then we have 5 here. We're going to feed this into... let's do this rail. That's 5, 10. So that's our lower half taken care of. So we need 2 more sets of 5 onto, say, these 2 bottom rails. 1, 2, 3, 4, 5 is being used for producing ceramics. Actually, 6 here are being used for ceramics. So we have 1 here. So here we have 1, 2, 3, 4, 5. Can I? And I know the answer is yes. Let's take this one. Let's put this down here. And we'll take rail connectors. We're going to reverse this so that these are pointing this direction. Actually, this already is, so we don't need this. We'll reverse this. run this direction. So this is 1, 2, 3, 4, 5. Now we want to take this into a rail connector running above. Right. And I'm going to take this all the way to the end. And we can do something. I don't know if we're going to be able to do it here, because this kind of runs through this spot. I'll test it real quick as soon as autosave is done terrorizing me. There we go. Go down. We'll go up, up, up. Oh, it is legit. Look at that. Okay. So we'll connect this to this. And then we'll connect this to this. There's 15 of the 20 we need. We have 1, 2, 3. I beg your pardon. I guess we don't need... We have 19, and we have 15, right? So that's 16, 17, 18. And I guess our last one is not going to be running at full capacity. But I need to get it over here first. But how? Without making these two towers touch. Because then they'll become structurally joined. Like so. Okay, and then we said we wanted to take partial of one of these machines to fill in, I guess, the whatever fraction of our 19th machine needs to be running. So we'll go from here. There. Now this machine will be split between these two manufacturing pipelines. And now I'm stuck in here. There we go. So let's go turn on our storage depots. The spaghetti is real. I don't know why I ran 6. We only needed 4. Right. So these just make a 90-degree turn and run to the back of these 4 storage depots, and then I'll distribute these to our furnaces along the front here. So we'll set these to Wolfram powder. That is not Wolfram powder. Actually, why did this not have a suggestion about what's available here? Something happened here with this last string. Let me chase this back. Oh, this is not... They traded places, that's right. Okay. So... These two need to go into these two, actually. Or we just trade it at the far end. I don't really want to mess with that, so I'll fix it at the other end. Get rid of this and this. And do this here. And do this here. And now we have the suggestion of Wolfram powder. Okay, so now we're good. Yeah, they got... At a certain point, I hit a rock and I had to move them around a bit, so they got... The middle and the outside lines got swapped around. So, this is 10 long. We have throughput for 5 furnaces out of each of these storage depots. Alright, our third rail will run to the left. So we'll put this all the way up here. Alright, so our first set of 5 will run into here. And then we'll do 1, this is 2, and 5. So we'll stop here, connect these up. There we go. And now we need to take a second rail, this high, but at this height. And we're gonna go all the way. Lock our Y right now. Locked our Y now. So this stops here. So we're gonna rejoin this right here at full height. Travel down this way. Jump back into here. And now we can continue running this to the left. Hook these up. There's Wolfram powder for our bottom row. Now I just need to repeat the process for the top here. Okay, come out of here, into here. We're gonna call this ASMB HE3RX3. Okay, everything's hooked up. I just need a little bit more helium. So, we're gonna set up some helium delivery to this receiver here. One, 2, 3, 4. Let's see. Can I handle it? Helium 3. No. HE3 RX3. Helium 3, HE3 RX3. Helium 3, HE3 RX3. Helium 3, HE3 RX3. These aren't even breaking a sweat. What if we did... Okay, we have helium. I wound up using some helium nodes here from where we had our sulfur base west in our main playthrough, just feeding into some dispatchers over to here. So these will run the 9 on this top row here, and then we have 240 left over here still to, I guess, fill in the gaps if we find that we're missing some, but we still need helium for something later on. Turbines or nozzles or something like that. So let me split... I forgot to split into 5 and 5, or I guess 5 and 4 up here, this output. So this is going to be 1, 2, 3, 4, 5. We're stopping here. And autosave, give me a heart attack again. It wouldn't be so bad if it wasn't actually crashing every now and again. You never know. Amazing. Okay. Moment of truth. Let's set all these to chemicals. Okay. They're all set. Now we just wait for items to come in. It's kind of hard to even look at it all. Everything is so squashed together to save space. But I see a bunch of green lights. A lot of green lights, a lot of green lights. Nobody's getting starved. Okay, so we'll let this run, but this was the last big hurdle. Let me pull up our chart here while this runs. So we still have 10 refineries for sulfuric acid. We have 10 fabricators for applicators. Those are half the size of what we just built here. And besides that, everything else is small. We've got 2 furnaces for electronics, 3 furnaces for inductors, 4 for heat-resistant sheets, and then our big manufacturing. We've got mega press, compounder, assembler, oh, and hardening agent. 10 hardening agents. So we're getting close. We're in the final stretch here. But once again, I'm going to take another break. This was a nice big chunk of time here, so we'll be back up in just a bit. Alright, let's deal with what will probably be our second biggest headache left here, which is applicators, heat-resistant shields, and inductors. We're going to have a little stack. So we're going to have a little stack of 10 fabricators for applicators, 4 furnaces for heat-resistant sheets, and 3 furnaces for inductors. So applicators are going to be tubes and glass. Now remember where glass is. It's one of these furnace stacks in the back corner here. Tubes I have to find again. Really could use some kind of labeling system like signs. Do you know what's making what without having to click on everything? Tubes, here we go, okay. 1, 2. So there's 3, 6, 9. And then one more will make 10. Pretty painless. And we'll put a platform here. There we go. So that'll be our applicator production stack. We're gonna need 2 ingredients for this, right? Tubes and glass. Let me just double check here. Applicator, tubes, and glass. Okay. Now, the question is though, so this is running every 4 seconds. So that's 15 cycles per minute times 8 tubes. So every one of these fabricators needs 120 tubes per minute, which means we can only fit 4 fabricators per rail, at least for tubes. So we have 10s, we have 4. So 1, 2, 3, 4. 1, 2, 3. In fact, let's make this a little easier on ourselves here. Let's take this one off of here. Let's do 4 and 4 in the second row. There. Now we have 4, 4, and each one of these rows of 4 is going to need its own dedicated V3 rail full of tubes. And then we have 2 extra on top here that'll need a half rail of tubes, or a V2 worth of tubes. All right. You save, just in case. Mother... Their little, like, pre-content 1 update that they released made this game way less stable. Tubes. Where tubes? Tubes here. Tubes close. Good tubes close. So we know this thing consumes a ton of tubes, but it only consumes 2 glass. So if we're running 4 seconds, so that's 15 times 2. So each one of these is consuming 30, and we have 10. So we need 300 glass between all of our fabricators here. So we can just run a single rail to all of this. We'll let him fill his buffer. He's earned it. All right, we'll close. We'll cut this. Because I want an extra output here. So I'll run this to here. Run this to here. And I want to send this up here. And then I want to send this up here. Send this through. And that should be everything we need for applicators. Let's set our recipes. Applicator. Okay, everybody's turning green. Let's take a look. I see lots of happy fabricating holograms. I think we are good. So many tubes. Look at all the tubes. My goodness. Okay, so that solves tubes. That was the harder one. Now we have 4 furnaces for heat-resistant sheets and 3 furnaces for inductors. somewhere. There we go. So you in there, and you in there. Okay, there's our 4 furnaces for heat-resistant sheets. Now we need to get plates, right? We use plates and sheets and something else. Heat-resistant sheet, Wolfram plate, titanium sheets, and glass. That's how we built these here, right? Because our glass feed is right here. Right, I think it's this one right here. So, let's put... We're going to intersect our glass feed right here. We'll run 1 to here, I suppose. Glass on the bottom. There's a single fabricator here. Hiding. I want to say it's this one right in the middle of the crosshairs here. There's one single fabricator making Wolfram plates. We need to get that all the way over here. I almost want to just put a Wolfram pipeline right there just for that plate, but we could totally do it. It would be so easy. That plate can stay buried in there. We're built on top of a Wolfram deposit. Wolfram plates. This needs 60 per minute. This is producing 60 per minute. Look at that. Now we have our Wolfram plates right here next to where we're going to be using them. We don't have to run a new wire through this rat's nest. We'll just take this. Nice and level. There we go. Okay. Local Wolfram plates. Bespoke farmer's market Wolfram plates. And then we need glass. No, we have glass. We need titanium sheets. We're gonna fly these through the sky. And then we need to bring these down into here. Look at that. It all worked out. Here come our plates. We'll go set our recipes, and we're done with heat-resistant sheets. Okay. Here comes everything. Glass, plates, sheets. We're furnacing. We'll let these build up while we go and take a look at our next target, which is 3 furnaces for inductors. And that's going to require tubes, wire, and ceramics. So tubes, well, wire and ceramics are on this side. So we may want to build these furnaces in some flat space over here on this side of the crater. Go as low as we can go. 1, 2, 3. There we go. These will be for our inductors. We're going to need 3 inputs. There we go. Now, to get all this stuff over here, so we have ceramics right here. You know what? One rail solution, I'll just reverse the direction of these 2, and we're golden. This should be fine though, so we'll go from here into here, and then from here down into here. There we go. Here comes some wire. Tubes. So we'll wrap this around here. And I think because this is so long, I probably should have been doing this elsewhere. I think we're gonna locally buffer. So we'll run this into here. Run this into here. Tubes. Inductors. I hear the sweet hum of manufacturing, of logistics. That's the sound of logistics in action. So that brings us to the final, what do we have here? 5 columns, of which there are only 34, 35, 36, 37, 38. 38 more buildings, and we're done. The big one is going to be the one that's annoying in every playthrough. The pipeline that goes from tubes to hardening agent to resin. So we need to set up, we have our, so we're extracting raw sulfur already. We need to set up our receivers to receive the sulfur here. I should probably keep an eye on our core level as well, our overheat level. We need to receive our sulfur here. It's going to be a significant amount of sulfur. And then we're going to have to build 10 refineries in a row somewhere, preferably. I don't really think you can stack refineries, but that's why I was trying to leave some flat open space back here to place 10 refineries, if we can. We'll face them this way, looking backwards. No. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. And we know that we can only fit 2 per rail. It's gonna look something like this. That'll be for sulfur. No!
I recommend finding a safe place.
I was just getting into the groove of it. Alright, I'll be right back. Okay, back to work. We need a cargo receiver for each pair of refineries here. I think I'd rather line it up with that, though. There we go. That'll feed in there. Okay. Now, you just need to keep in mind that we need 2 more refineries here. We need to keep some space to squeeze this in, maybe further up the hill. Right there. And that should be everything we need for refining. Sulfur. Now, we have to set up each of these receivers and then get a steady 480 sulfur per minute into all 5 of these receivers. We'll start here. ASMB Sulf RX1 RX2 RX3 RX4 RX5. Confirm. Alright, we need to get power into all these. Temporarily. Get all these online. How's our power looking, by the way? Can't tell. 5790 of 6400. We still have a little bit left. Okay, so let's get out to our sulfur base. We'll probably actually have to set up, based on how I set those rails up for the supplementary dispatchers, we might need to hit up another sulfur location, but that's fine. I have several bookmarked. Let's save and cross our fingers that we don't crash again, please. For the love of all that is holy. We're good. Okay. Sulfur pit. Well, let's see. So we're gonna do sulfur ore. Sulf RX1. Sulfur ore, Sulf RX1. Sulfur ore, Sulf RX1. Now 3 dispatchers will not go uninterrupted. RX2. There will occasionally be a time when their countdown timers, their 10-second countdown timers, will overlap and you'll have nothing left in your receiver to output because it's waiting on all 3 of the dispatchers to start transmitting. 3, 3, 3, 4, 4, 4, 5, 5, and 5. So what we may need to do, I'll have to keep an eye on it, but I suspect that I'll have to go to one of our other sulfur locations, like Sulfur West over here, and set up one sulfur extractor each to act as the supplementary dispatcher for each of our receivers. So we'll need potentially 5 more. Okay, we have sulfur. Now, we need chemicals. So, we're receiving... We need 1 chemical, which means if we can run 2 refineries off of... If 2 sulfur ore every 0.5 seconds is 240, then 1 chemical every 0.5 seconds is 120. So we can run 4 refineries off of 1 480 item rail of chemicals. So let's see how many chemical furnaces we have to string together to fill a rail. We can string together 4 furnaces for each pair of refineries. That'll be 60, 120.
Arcadia 7 has finished regenerating.
Then 240. And all we have to do is just pass it up over this big open platform, which is not a big deal. Let's see how this is gonna work. 1, 2, 3, 4. So we'll take... Oh, I missed. So if you wrap these around like this, and like this, or if it'd be easier to just do this like this. And we send 1 this way, 1 this way, bring this straight into here. And we can put this back here, run this out of here. Nope. Run this out of here, run this into here, and then run this into here. Yeah, and then we can set this to be sulfuric acid, this to be sulfuric acid. Each one of these is getting 2 dedicated furnaces. Oops, I didn't connect this back up. I was like, why isn't this getting sulfur? That would be why. Why is this one going crazy and this one's choking? I don't get it. Let me get up here. Set this to sulfuric acid. sulfuric acid. And this sulfuric acid is used in like everything else that we're creating. It's used in turbines, batteries, hardening agent, most of all. Okay, so here are all of our refineries, our 10 refineries hooked up, receiving, manufacturing sulfuric acid. So now we have to split this up into 4 different manufacturing pipelines. We need 10 furnaces for hardening agent, which will be our last big stack of buildings. That's going to consume 720 sulfuric acid per minute, which is a full 480 item rail plus a 240 item half rail. So each pair of these is producing 240, or I guess we can technically say each one of these is producing 120. So we can nice and evenly divide these up, so we can take 4 of these together to give us 480 on one rail, and then take another 2 for 240 on a second rail, and that will supply all of the sulfuric acid that we'll need for hardening agent. And then the rest of these will go to producing batteries and a couple of other items. But yeah, we'll need to find a place to put our stack of 10 furnaces for hardening agent that is close to our refineries for the sulfuric acid, and is close to synthetic silicon. And then we also need applicators, which should be right over here, I believe. Is the applicator stack here? I think silicon is right here as well, so maybe we can fit this stack in of 10 furnaces somewhere right here. I think this would be the nice nexus meeting point of all of these manufacturing lines that we're going to need. Let's take a quick gander at this. I'm going to turn off the overlay or the HUD. We're going to zoom way out and look at all of this nonsense that we have in here. I can't even fit it all on the screen. Okay. So if we can put our furnaces for hardening agent, maybe like right here? We need 10 of them. One, 2, 3, 4, 5 is 10. I think that might just work. Let me get closer. So we'll need 3 items for each of these.
I'm so hungry, I feel sick.
Right, let's take a look at the recipe. So hardening agents. Every 4 seconds, we need 5 sulfuric acid. So 60 divided by 4 is 15 times 5. So that's 75 sulfuric acid per furnace. So we can feed 6 furnaces with a 480 item rail. We can do 1, 2, 3, 4, 5, and then 1 in the second row. So here's a question. Do we do 6 and then 4 instead of doing 2 tiers of this? Will that make our lives easier? Can I fit? I can definitely fit 6 in here, like this. Yeah, we have enough to get a rail out of there. So this could be 1, 2, 3, 4, 5, 6. In fact, we wouldn't even need the gap in between it, but we'll leave it just in case. And then we would just need 4 over here. 1, 2, 3, 4. Might make getting items through here a little interesting. Can we go over one more, perhaps? No, we're right up against that. Can we move this? We can probably move this. There we go. Now I can take maybe this guy out of here and put him over here. 1, 2, 3. Sure. I'm not sure how that's supported, but we'll take it. This should go into here. Everything comes alive. All right. Sulfur's moving, at least to one of these. So we know sulfur's hooked up. Next, we're going to need applicators and synthetic silicon, right? Yes. So we're consuming 1 every 4 seconds here. So that's 15 times 6. So we only need 90 of each to run this. Okay, there's synthetic silicon. Okay, here comes applicators. Now I just need to repeat this for our separate 4 here. Okay, that works much better. So both of these refineries should be able to work off of a single 480 item rail, but they seem to struggle. I think the production time is so low that even though the items are on the way, the 0.5 seconds is not long enough to get from here to here. So if I just run the second refinery off of the back of the receiver, and then each one has its own dedicated 480 item rail, and now everybody's happy. Right there. Here it comes. Hitch a ride. Meow. Thank you. Okay, so we'll set this guy here. Let me up. We'll say you to hardening agent. Hardening agent. Hardening agent. Here come applicators. Here comes whatever else is in here. Silicon and sulfuric acid. So now we need to merge the outputs of these 4 and these 6. And these are going to produce, this is every 4 seconds, we're making 2. So that's 15 cycles times 2 is 30 items per minute per furnace. So that's 300. So we can fit all of these on a single V2 or V3 rail. Feed that in the back of there. And then into here. Beautiful. Okay, and then... Oh! That better be an autosave. No! I couldn't control my jump because it was autosaving. Alright, so hardening agent. I want to see hardening agent flowing from every corner. I don't know why it doesn't accept from both sides at once. Like, yes, this rail is full, but why isn't it pulling anything from this side? We have hardening agents available. One single hardening agent. There we go. Now we're getting some. But yeah, there we go. There's hardening agent off the list. So, we are in the final stretch now. Because that was the last stack of, like, multiple of things. Well, I mean, we still have a few, like, 1 or 2. I think the most we have left to build is a series of 5 compounders for synth resin, but yeah, the rest of this is easy sailing. The only hard part from here on in is going to be getting things to where they need to go. Space is becoming a commodity in the crater here. We have to squeeze in, let's see, 2, 3, 4, 5, 6, 7, 8, 9, 14, 15, 16, 17 more buildings. And we're done. So, from here, we've got most of our nightmare tech chain down. We've got tubes, well, technically rods to tubes, to applicators, to hardening agent. We've got sulfuric acid coming in. From hardening agent, we have to go to synth resin. 1, 2, 3, 4, 5. So we have to bring, to get all these even, we have to bring these up 2. Okay, that's not that bad. Synthetic resin. Runs every 3 seconds, consumes 10 calcite sheets. So that's 200 calcite sheets. So we actually need 1,000. Although, according to the chart here, one of these compounders is only going to run at 0.8. Only run at 80% efficiency to meet our required output, which will bring it down to 960 from 1,000, which we can do. We can do 960 across 2 rails. 1,000 would take a 3rd rail. Let's do it in the center and then go out. Middle out. We'll go this way. That way we can do a big old rail connector here. That will accept this rail. Nice and straight. I didn't even plan that. I love it when that happens. From here to here. To here. To here. And then we just have these meet in the middle in this guy. And then he can pull from wherever he wants. Now we just need to get sulfuric acid and hardening agent over here. Through here. Into... Yeah, we could do it like that. We can do it here. Or we can do it here. We'll do it there. Because then if we're coming up from the ground, it'll be way easier to connect it into this than this. Let's go find our hardening agent. Probably want to locally buffer this. Because this is quite the run. But like, where? Like that. And then... like that. Alright, hardening agent. Well, I think we're ready. Synthetic resin. Synthetic resin. And this is already set. This is waiting on hardening agent. Everything else is flowing. I see sulfur, or I see acid even. I see hardening agent. I see calcite sheets. I hear industry. That's not good. Oh, you know what I can do? You know what I can do? Is put this at a low priority. What is this producing anyway? This is 1 every 3 seconds. Good God, this is slow. That's 20 times 5, we're making just 100. 100 per minute across all of these? That's crazy. That's like not even a V1 rail full of these. So let's set this to synth resin. I want to see how these calcite sheets behave once all these are running again. Okay, so it's pulling 10 at a time. And then once this starts emptying out, I think this one, this middle one, should just get choked out forever. Because I don't know if this will ever be fully filled. There are an occasional calcite sheet reaching this. It's not hitting replenishment levels, but that's fine because we know this one's going to only run at 80% efficiency. Okay. But for now, I guess we're going to go hide from the Ruptura for like the 9,000th time this build. So now we need 3... How much do you drink? This lady drinks like 5 times more than I drink as a real living human being. One, two, three. Lens, we're gonna need to get glass, hardening agent, and synthetic resin over here. Synth resin is easy because it's right here. We can take this directly into... I guess we'll go to the lowest one. Oh, we finally hit our power budget. One, two, three, four. Touch. And we're back online. Man, I really want to stack those compounders. I know we can do it. It's just going to make getting items into them more annoying. And I just kind of want this build to be done. Now let's get hardening agent and glass, which should be on this side. Which is both good and bad. Oh, actually there's the hardening agent right here.
Has finished regenerating.
Break me off a piece of that. And we'll go into there. This into here. And then this into here, right? We'll set this to glass. Here it comes. There it goes. Such a ridiculous path for this to be taking. It's literally zigzagging through the air. Like a roller coaster. Okay, we're rocking lenses. With that done, we're down to our last 4, 5, 6, 7, 8, 9, 10. Our last 10 buildings. So we need a single mega press for batteries. We need a single furnace for electronics. No, we need 2 furnaces for electronics. We need a mega press for impeller. So let's start with electronics. Furnace. Times 2. Alright, so we have inductors here. Inductors. There we go. And I need to get these into... These definitely need to be buffered, because these are coming from so far away. Literally the other side of the base. I'll put these into here. We'll request stators. We're gonna give this like 45 minutes for these things to get over here. Here comes stators. Alright. Alright, there we go. Stators. Electronics. One more thing down. Impellers and nozzles in a mega press. We're just sending this stuff wherever. I'm at the I just want this done point. So we're just hook it up. I don't care which way it goes. I'll cook however many plates of spaghetti I gotta cook. Here we go. Impellers. Online. Okay, now we set this to helium-3. Okay. That's nozzles, electronics, and impellers. We have batteries, turbines, generators, and we're done. I guess let's just come off of this. Let's just keep going this direction. The electronics are just used for batteries. And there's one. Inductors is here. Sulfuric acid. Come on down. Sulfuric acid. Okay. One more down. We need 2 mega presses for turbines. Turbine. We just need to get impellers over here and rotors over here. I don't know where rotors live. So stators, blah, 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 blah. Make them over here. We can continue another line. stators, sulfuric acid, impellers is going to be a long trip. How much of each of these have we been producing? We're producing... We can send these both on the same rail. This is going to be so against everything I stand for, but we can put these on a single rail and send these across the map. It's okay, we'll do one here, one here. We need to break these off into impellers and nozzles. Impellers, and then we have to find out where rotors are again. Okay, I also jumped rotors off of this, because this is not a very heavily loaded line between the output of 2 mega presses. We'll feed these into here, and now we have everything we need for turbines. So we have just 3 buildings left. We have to make 2 assemblers for generators, and then an assembler for scanners. And we are done. So generators take batteries, turbines, and electronics, all of which is here. So let me save. One and 2. Making generators, turbines, batteries, nozzles. Nozzles are here. You. Batteries are here. And the output of this, right? Turbines. We should be able to actually just combine these into one rail, because they're both going to the same place and nowhere else. And there we go. We need this 3rd rail. Everything's coming in on that rail. Alright. The generators are running. We've got more than enough input to run these at full efficiency. There's our 2 assemblers making generators, so now we have everything we need for scanners. We're going to do something a little special with our final assembler. Okay, so we're gonna set this to scanner. We need lenses, generators, and stabilizers in here. Generators. Okay, I just gotta get stabilizers over here and we're done. There we go. You'll be stabilizers. We're just about done. We're gonna spaghetti this. We're gonna just pour a whole pot of spaghetti down this hill into here. And we've done it. Here come our stabilizers. We are officially manufacturing scanners. It's finally done. It only took 20 hours. Now, obviously these numbers are way better than they were in our main playthrough with the mega assembly line, but we won't know that this is truly running at 100% efficiency until we leave this running for probably an entire rupture. Like this rupture just started, so I'll leave this running. We'll keep an eye on our storage depots back here, and we just want to make sure that we don't necessarily need these to fill up, because I think the generators are being produced at the exact rate that this assembler is going to use them. We just need to make sure that they're not depleting. And if they're not depleting, if we're still running at 100% efficiency by the time this rupture is done, then I'm going to say that we have done it, and we have created, in this one crater, except for all the raw resources, of course, all 468 buildings required to run one assembler, creating scanners at full efficiency.
I'm detecting increased rupture activity.
Sorry.
Prepare for a wave.
I was out riding my rails. Let's go take a look and see where we're at. Okay, we're still running. We're still at 100% efficiency. We're still full up. And we're at about the same level we were on all of our storage depots here. We're at mostly full. I can't tell if we actually lost any here, if it just never full up in the first place. We're full here. And we're at about 80, 90 here. So yeah, I'd say this has been one full rupture, and we've been running non-stop. We haven't lost any of our stockpiles of goods for our assembler, so I'm gonna go run from the rupture before I get blown up, and we'll do a little outro. All right, now that we have some sunlight out here, let's take one more sweep over the base that we've built here. According to the build guide, we've got at least 468 buildings, all feeding into this one machine here. Probably more than that, because I went a little above and beyond with all the dispatchers and whatnot. And we did have to tap into some additional helium and some additional Wolfram to fill in spots. But now that it's all here, we can get a good idea of just how ridiculous the exponential growth of the resource requirements in this game are. And this is just the materials and buildings available in the base game. Once Update 1 finally releases, we're going to have to bump this up to around 950 buildings to build the highest tier item in Update 1. So hopefully we'll have some better looking alternative recipes in that one to cut down on the raw number of buildings and materials that we have there. But I'll put some totals in here on just how many items per minute we're building here. But it was about I don't know, 20-hour build total. I did start from my existing save from my main playthrough, so I didn't have to unlock any technologies. I still had all of the building materials left over from deconstructing the mega assembly line, so I cut a lot of time out on that. But still, 20 hours was more than I was expecting, honestly. Probably would have gone a bit faster if I wasn't crashing so much. I think having just this many buildings in one place is making the game a bit unstable. I was crashing about once an hour and losing about 15 minutes of progress every time, so pushed the build time out a little more than I would have liked. And then, of course, you have the mandatory go stand in a room and wait while the rupture passes, so it is what it is. I think it was time well spent. We made a pretty cool little prototype base here. I'd say we successfully completed the challenge, and Update 1 releases in less than an hour, but I think it's going to be time for me to go hit the hay. So if you made it this far, thanks for watching. If you enjoyed this bonus build here in StarRupture, hit like and subscribe. If you want to check out StarRupture for yourself, head on over to Steam and pick it up. And if you want to let me know what you think of the build, then hit the comments down below. But whatever you do, I'll see you right here again in the next one. So, until then, bye-bye.